ಇಲ್ಲ ಸಿಸ್ಟಮ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಕನೆಕ್ಟೆಡ್ ಮೊಬೈಲ್.
Today also same case happened. Question is downloaded. It's not being downloaded. I have.
Hello.
Okay, good morning, sir. There was some
Very,
technical problem. Sorry, sir. Sorry for
No
the
issue. No issue. No issue.
There was
Let's
some
wait. Let's
technical
wait. Let's
problem
wait.
in YouTube.
No issue.
Very good morning to everyone present here. I hope you are doing well, staying safe and healthy during this unprecedented time. I'm Asta, and before we begin, let me share a beautiful quote by Ginny Rometty on artificial intelligence. Some people call this artificial intelligence, but the reality is this technology will enhance us. So instead of artificial intelligence, I think we will augment our intelligence. So it gives me immense pleasure to welcome you all to the AICTE training and learning ATAL sponsored 1 week online faculty development program on data science and artificial intelligence in chemical engineering, recent trends and future outlook, organized by the Department of Chemical Engineering in association with IIC and IQAC MVJCE. We are delighted to announce presence of eminent speakers with us who have expertise in the field of AI and data science. It is indeed a privilege and honor to have Dr. Ravindra D. Gudi sir, professor in charge of IIT Bombay Research Park Foundation, with us today as our chief guest despite his busy schedule. We thank all the participants for their time and interest and also for registering for this program. So let us make sure that all the efforts and your time are going to make this program a grand success and a tremendous knowledge sharing platform. So now I would like to request the event coordinator, Dr. Manisha Bal ma'am, to share us some insights of this faculty development program.
Thank you, Asta. A very good morning to everyone. I hope you all are staying safe and healthy in this tough time. Before getting into more details of the program, I would like to thank you all and extend my gratitude for taking out your time from your busiest schedule, and thank you for joining us today. Here I would like to share a brief of this FDP program. ATAL program is an initiative by AICTE which aims at empowering faculty to achieve goals of higher education such as access, equity, and quality. These programs have been designed to fulfill the need to train the younger generation in the skill sector and also to have faculty and technicians trained in their respective disciplines. Today, the world is moving towards automations. Even the chemical industry is starting to adopt such practices. Thus, the use of data science in the chemical industry has increased significantly in the last few years. Every experiment starts from a simulation of a process in the laboratory, and data science helps in scaling it from large scale to plant scale. Even with the help of artificial intelligence, we can make predictions on mathematical models and make our simulation process a strong backbone. It helps to make strong and firm research decisions and makes the time in many ways. Hence, with this FDP, we want to inculcate within the research minds and faculty about the data science and artificial intelligence for chemical process engineering operations that could reflect the interest and to prepare the student as competitive professional in the growing era. So following this FDP program, we are going to organize 15 sessions where 13 of them are going to focus upon technical aspect, keeping the program topic in mind. And in the middle, we are going to have a stress management session through Sahaja Yoga meditation. At the end, we are going to conclude our long 1-week program with a validatory session followed by a final test. All the participants having 80% of attendance and 60% marks in the final test will be eligible for the FDP program certificates at the end. Feedback link will be shared after each session to track your attendance. Click link will be open till 5 p.m. So final test will be conducted at the end of the program. So program information brochure and session schedules are already shared with the participant over their registered email IDs. So for any further communications and for receiving prompt response, I would request all to join our FDP program WhatsApp group, which link is also shared over the registered email IDs as well. Thank you once again for participating in this FDP, and we are truly looking forward a holistic success at the end of this long 1-week program. Thank you.
Thank you, ma'am, for sharing the vision of the program. Now I would like to invite Professor Atira Ashokan, ma'am, Head of the Department, Chemical Engineering, to share a few words with us.
I think you're muted, Professor Athira. You're muted. You need to unmute.
Okay, sorry, sir. Am I audible now?
Yes, yes, madam. Yes, madam.
Okay, thank you, sir. Thank you, sir. So, respected dignitaries of today's session, our chief guest, Dr. Ravindra Gudi, sir, Professor IIT Bombay, Dr. Mahabaleshwarappa, sir, Principal, MBJCE Bangalore, heads of various departments, faculty members of Chemical Engineering Department, and dear participants of FDP from various institutes and industries. A very good morning to one and all. It gives me immense pleasure to welcome all of you to the opening ceremony of ATEL sponsored 1-week online FDP on data science and artificial intelligence in chemical engineering, recent trends and future outlook. At the outset of this inaugural ceremony, I am very happy to share with you that the Department of Chemical Engineering, MBJCE, was established in the year 1984. MBJCE is one of the top chemical engineering colleges in Bangalore, which provides unmatched learning experience to students. The department is showing continuous academic excellence by securing more university ranks. MBJCE and the Department of Chemical Engineering follows OBE and experiential learning approaches. Many of our graduates are working in reputed industries. The department is accredited by NBA New Delhi for 3 times, presently accredited till 2022. The department has well-equipped infrastructure support with a vision to provide quality education. The department also encourages industry-institute interaction for students to bridge the gap between industry and institution. The department has handled several projects by various agencies like sponsored by ASCT, CSIR, IACHE, KSCST, and BGST. Guest lectures and FDPs are arranged by eminent personalities from industries and research institutions through the department associations to develop the overall personality of students. National level conferences, workshops are organized every year in association with the student chapter of IACHE to enrich the knowledge of students beyond curriculum. I wish all good wishes for the participants. Thank you, sir. Thank you all.
Thank you very much, ma'am. Now I take this opportunity to invite Dr. P. Mahabaleshwarappa, sir, Principal, MBJCE, to address the gathering.
One second. Very good morning to everyone connected to this 5-day FDP program on the application of data science, artificial intelligence, and machine learning in chemical engineering and its industries and future outlook, which is organized by the Chemical Engineering Department of the MHA College of Engineering. This program is sponsored by AICTE under Atal FDP scheme. Because of the current situation and the pandemic, we could not able to organize in our campus. Principal Madam Dr. Brindayam, respected Registrar and Controller of the Examination of our institution, Professor Vaman B. Gudi, respected Professor and HOD of the Chemical Engineering Department, Professor Atira Ashokan, HODs of the various departments of our institution, faculty members of the Chemical Engineering Department of our institution, faculty members who are participating on this auspicious occasion of in chemical engineering and its industries and future outlook. When you look at the current the scenario, world is growing at an unprecedented rate, especially during this academic year 2021, has shown us that the advancement in the kind of advancement in the science and technology, that too in the field of the chemical engineering, wherein very, very widely used for the process optimizations and digital sensors for quality control and to have a quality product outcome. AI and machine learning play a very, very vital and integral role in effectively taking the chemical industries towards the trend. The current excitement about the AI and ML, particularly ML, is to revolutionize. There is also a great interest in the commercial potential of AI, which predicts the potential impact of AI in several domains, all driven by the sudden explosion of surprising advances, which has happened and occurred when we started using the AI and ML, has made, and it has been visible in the last 10 years. Many of the chemical industries are touching benefits of leveraging AI and ML to analyze data, optimize processes, and mitigate the errors by minimizing the manual interventions. Human-machine combination is providing to be a transformational phenomenon that can change the way of chemical industry is functioning by usually using the AI and ML effectively. With this, I take this good opportunity to convey my thanks to the Department of the Chemical Engineering and the various coordinators and the organizers of this 5-day FDP, and having invited me on this auspicious occasion to inaugurate and to address all of you on behalf of the management, and especially on behalf of our institution, and particularly on behalf of the Chemical Engineering Department. I'm extremely happy to declare that this program, the 5 days FDP program, is being inaugurated on this day for the benefit of the earning a knowledge, something special which is not available in the book materials. So when we interact with the learned people and the experienced and the faculty and the industry people, then only we can able to earn a latest things what is being practiced in the industries. So with that, the keeping in the vision and the motto, And this is the FDP. It has been sponsored and it is organized by the Chemical Engineering Department of our institution. On behalf of the management and especially the institution and the Chemical Engineering Department of MEJC, I wish that it is going to be a very successful one and reaching all the faculty members who are participating in this 5 days of FDP from the premier institutions. And I once again wish for great success. Thank you one and all.
Thank you, sir, for your delightful words. Now, with greatest pleasure, I would like to invite today's Honorable Chief Guest, Dr. Ravindra D. Goody, sir, to share a few words with all of us.
Hey, good morning, everyone. It's always a pleasure to interact with faculty colleagues in chemical engineering across the country. Something very special that we always look forward to. So I think enough has been said about the AI and ML, and I think even Asta mentioned about it being, artificial intelligence, but also something which is helpful in augmenting our knowledge. This is something that is increasingly becoming important. It has been cyclic. For instance, late 80s, mid 90s, we had a lot of activity in this area, research activity as well as implementation advancement into the industry. And then for some time there was a lull, and now with the advent of computing and related infrastructure as well as the communication technologies, data sciences, but leading towards artificial intelligence and more advanced variants of that, is something that has come into vogue not only in operations but also at discovery levels. How do you go from discovery, development, demonstration, deployment, the 4Ds as it is normally called. At each of these steps, some of these developments are increasingly finding a translation into practice. And it is good that, when we teach our students, we do establish a broad foundation in chemical engineering for them, but also at the same time, we need to make sure that they are aware of the current trends. And, this is indeed a very timely organization of this faculty development program. To me personally, FDP is a misnomer. I would not call it as faculty development as much as I would call it as a faculty interaction program, because I'm also learning here. And I think through interactions, we basically develop further the state of the art, train manpower, and as we go ahead, we basically try to establish success in this area. So quite really, I think it's a pleasure again to be here at MB College of Engineering to share my research in this area. I think that's all I have to say. Again, I wish to thank the management and the department at MBG for inviting me to participate in this nice initiative. Thank you.
Thank you, sir. So moving forward, allow me to invite Professor Chaitra D. ma'am to propose the vote of thanks.
Thank you, Asta. A very good morning to all. It gives me an immense pleasure to deliver the vote of thanks for this event to all the dignitaries present here. First and foremost, I would like to thank AICTE for providing assistance and sponsoring for 1 week faculty development program. On behalf of management of MVJCE and Department of Chemical Engineering, I would like to convey my sincere thanks to the Honorable Chief Guest, Dr. Ravindra D. Goody, sir, who, despite his busy schedule, has found time to grace this occasion and honored this program with his inspirational thoughts. Thank you, sir. I would like to express my gratitude to the management of MVJCE and Principal Dr. P. Mahabaleshwarappa, sir, for enlightening the importance of this 1 week faculty development program and guiding us to make this event a great success. Thank you, sir. I take this opportunity to thank our beloved Vice Principal, Dr. Brinda ma'am, for her continuous support and encouragement in all our efforts. Thank you, ma'am. I thank our Controller of Examination, Professor Vaman B. Gudi sir, for his valuable guidance and support. I also thank Professor Athira Ashokan, Head of the Department, Chemical Engineering, Event Coordinator, Dr. Manisha Bal, and all the faculty members and the head of the departments of the Chemical Engineering for their sincere assistance, who have worked hard to ensure that this occasion becomes a memorable success. Last but not least, I take this opportunity to extend most sincere thanks to all the participants for engaging your valuable time to this program and share your knowledge. Thank you all. I hope you all have a great time during this 1-week faculty development program. Thank you.
Thank you very much, ma'am. Everyone, let us begin with the first session for today. I would request Professor Chaitra D, ma'am.
Asta, you're not audible.
Oh, I'm sorry, ma'am. Is it fine now?
Asta, you're not audible.
Is it fine, ma'am?
Yes, Asta.
Sorry about that. So everyone, let us begin with the first session for today. I would request Professor Chaitra D, ma'am, to introduce the guest speaker for the session.
Good morning, all. It is a great pleasure to introduce the guest for the session, Dr. Ravindra D. Gudi, sir. Dr. Ravindra D. Gudi, sir, is currently Professor in charge of IIT Bombay Research Park Foundation. He has served as head of the Department of Chemical Engineering at IIT Bombay and also the Professor in charge of Continuing Education and QIP. He also holds the Institute Chair position in Artificial Intelligence and Machine Learning. He earned his BTech and MTech degrees from IIT Bombay and PhD from the University of Alberta in 1995. His research interests lie broadly in process systems engineering and green engineering, that is, modeling, optimization, control, and fault diagnosis of process systems, sustainability in industrial practices. Dr. Gudi sir has served as a visiting professor at the Department of Chemical Engineering, University of Alberta, Canada in 1997. Department of Chemical Engineering, University of Wisconsin-Madison 2003-4, and the EECE Department at Washington University in St. Louis in 2015. Dr. Gudi sir has published over 135 Scopus indexed papers and has 9 US patents to his credit in various areas of process systems engineering. He has guided over 60 PhD and MTech students in their research at IIT Bombay. Dr. Gudi sir is a recipient of several awards, including the Canadian Commonwealth Fellowship by the Government of Canada from 1991 to 1995, Lavraj Kumar Memorial Award for Promotion of Industry-Academia Interaction, July 1998 to January 1999, Manudhane Applied Research Award in 2006, Hedelia Award for Excellence in Basic Chemical Engineering in 2009. He is also an associate editor of the IFAC Journal of Process Control and guest editor for Control Engineering Practice. He serves on several technical committees of IFAC and is currently a member of the IFAC Council. He has been an active consultant to the industry in India and abroad. He is also currently the president of the Automatic Control and Dynamic Optimization Society of India. With this, I welcome you all to join us for the first session on digitalization, artificial intelligence, and machine learning, exciting opportunities in engineering by Dr. Ravindra D. Gudi, sir. Over to you, sir.
Yeah, thank you. Thanks so much for the very kind introduction. Just a small correction. My term as the president of ECDOS is complete, I think, in December of 2020. So it's a correction, but yes, thank you so much for this very nice introduction and again for this opportunity to be able to share my interactions, my research with all of you. Let me begin by sharing my slides here, and I think I have approximately an hour and a half, and I will switch between slides from two presentations. But primarily what I would like to ask is that we should have a very tight interaction during this presentation, because without that, it really doesn't result in very strong pitch for me. I typically like to get a pulse of the audience and the participants. So I have titled my talk in three broad aspects. One is digitalization, which is increasingly becoming or taking over, or has already taken over, if I would say, in a regular day-to-day life, but also in a majority of industrial practices. Talk about artificial intelligence, but stress, as indicated earlier, on augmented intelligence and machine learning. There are several exciting opportunities, as you may find, in research, but also increasingly in the industry, in a variety of domains: healthcare, finance, marketing, engineering. Um, it's an explosion that's happening out there in terms of leveraging the power of artificial intelligence into each of these domains. And it's time that we not only educate but encourage our students to basically jump onto the bandwagon with a little bit of caution, which I'll emphasize during my talk, of course. And have primarily talked about in this talk, I'll focus mostly on operational excellence, but I'll just make some comments about the design aspects as well. AI and ML is basically, as understood in common parlance, artificial intelligence and machine learning, basically leveraging so much of wealth of knowledge that's present in the data. But I think it's time that we also bring in the perspective of our physics understanding into all of this, so that the overall power of decision making is substantially enhanced when we bring in our physics-based understanding and the data-based understanding. Okay, so I've given this talk earlier, and some of you may probably recognize this slide. This slide is deliberately taken just to illustrate to you what are we staring at in terms of the complexity of application, in terms of what we can do in real time. Okay? I also want to bring in the notion of a digital twin here, more in the context of engineering practices, and want to emphasize to you the 5 V's that we are talking about in data processing, data analytics, machine learning, and the like. So this is a simple example of boiler where there is a fuel that goes in and there is a gas that is generated, rather a flame that's generated. The flame impinges on boiler tubes, causes evaporation of the water into steam, and depending on the pressure on the boiler side, you will get either high pressure, medium pressure, or low pressure steam. As such, a very simple application. It's been in vogue for years, decades, I would say. However, efficiencies have been typically quite low, and there is an enormous potential if you are able to leverage data sciences, the power of data sciences and first principles knowledge to be able to improve the overall efficiency of the combustion. So that's the objective here. If you see on the bottom right, it's high efficiency combustion that we want to realize. What does that mean? Stepping back, high efficiency essentially means that you have energy locked into the fuel, which gets released when you burn it. That energy you want to transfer to the maximum extent possible into power generation. And so you measure that, you measure the efficiency, and typically those have been low because there have been losses, there has been inefficient combustion. Not all of the energy is released from the fuel because of aberrant operations and the like. And so it's a good idea to start looking at how do we improve this aspect, the upstream or the furnace side of things. Of course, there is a lot that can be done on the boiler side as well. In fact, several papers, including one of the industry applications we're currently doing, focusing on the boiler side. But even on the upstream side, the furnace side, there's a lot of opportunity here and more impactful, I would feel, than looking at the boiler side. So if you look at this, and we say AI and ML, we start looking at what kind of data do we have. The first thing you can see here is fuel quality sensors. The sensor, the fuel that's typically fired can come from a variety of sources. It might have a variable calorific value. You sense the fuel quality and determine what's the energy that's going in. When a fuel burns, it produces a lot of sound, as some of you may be aware. When you operate a gas stove at home, you can see a hissing sound. Depending on the frequency of that hissing sound, you can determine what is the rate of firing and what's the efficiency of combustion. Acoustic sensors can be deployed here. Thermal sensors are another aspect that is typically located in the ambience around the flame to be able to sense the environment around it and see whether there is any loss that's happening. Now there is a huge opportunity here with thermally shielded cameras that can be placed to measure the flame health. What do you mean by flame health? Typically when a flame burns, the flame can dart, the flame can shrink, the flame can appear of a different color depending on how much of combustion is happening. And you want to ensure that there is a steady flame with the right kind of conversion of the fuel energy into the flame and then to the boiler tubes. So you want to monitor the health of this flame, and the color of the flame typically can give you a good idea of what's the health of the flame. For example, if it is orange, then there is a sooty flame. If it is blue, it's clean burning flame and the like. So flame images also get taken nowadays, and typically more than one camera. So 2 or 3 cameras placed at appropriate locations that give you an estimate of the volume, the color, all of those parameters. And then you need to do a parameter extraction, the color classification and the like. And then finally, of course, you have emission information. You can basically have mass specs kept at the exit, do an exit gas analysis to find out how much carbon monoxide is there if it's incomplete burning, the temperatures, the sensible heat loss, and the like. Now, all of this primarily are in the domain of what one would call as machine learning. If you start looking at the data from this, and it has its own challenges. What are the challenges? For example, you see amongst the 5 V's: volume, velocity, variety, veracity, and the 5th one is value. Each of these sensors are basically differing in extents of what their attributes are. For example, if I take a look at the overall set of sensors, there is a huge variety in it. If I look at the flame images, they hit you at a speed at several frames per second. Velocity becomes important. So variety, velocity. Not all of these sensors are equally accurate. So there is veracity or uncertainty associated with the measurement. Okay. So we talked about velocity, we talked about variety, we talked about veracity. Volumes, the 4th V, the huge amount of data that gets built into the process history database when you're doing manufacturing. So volumes are huge. Okay. And finally, the value. Amongst this, the direct value of what the combustion is happening is the flame. All of these do give you some extent of the health of the flame, but the direct, the highest value is for this flame images. Okay? So basically, processing all of this information or data is something that is typically done in a combustion quality assessment. Okay? Now, I would just like to pause here and say that while this is a simple application where it transforms the fuel energy into power, this is not restricted only to a boiler application. Let's take nanoparticles. Nanotechnology is a huge emerging area. Nanoparticles are made. Okay. Some of the methods by which nanoparticles are manufactured are in aerosol reactors or flame reactors, inverted flame reactors and the like, where a flame is burnt deliberately with the intent of producing nanoparticles. Okay. Even there, all of this in terms of the morphology of the nanoparticle, in terms of the size distribution, in terms of the characteristics of the nanoparticles, all of those can be monitored eventually. Okay, so while we are talking here only of combustion, we could also talk about product quality, nanoparticle product quality. Okay. So it has pretty much diverse applications. Coming back to the combustion application, here what you would assess is the combustion quality. What does that mean? When you accumulate all of this data together, there are periods when the combustion quality efficiency is very high. There's certain instants or periods of time when the combustion quality is low. You would assess the quality relative to the best efficiency that is measured in practice. And then you will compare the current operation with respect to that, which is really benchmarking. Okay? Establish a benchmark, look at the current operation and compare the two and say, okay, here is the efficiency of combustion. How does that help you? Well, to some extent it helps because if you're staring at a screen that gives you the efficiency of combustion relative to the best known, then you can go and query what are the bad actors here and go after them, correct them so that you try to push the efficiency as close to the known best efficiency as possible. But then the question you ask is, what is this best efficiency benchmark? Can I exceed it? Can I go beyond it? And that's where this concept of a digital twin comes in through the use of physics. Now, this combustion system model is basically a physics based entity there, which models the mechanisms of how a fuel burns, reaction mechanisms, the kinetics, the release of energy, and all of that. What I would like to do is exploit the first principles knowledge along with this to push the benchmark higher. Okay, because how do I know that I can't do better? I might have a bunch of operators who come and operate this furnace. Some of them may be exceptionally good in their job, some of them may be not so good. Now the best operator has a benchmark, but how do you know that that cannot be exceeded? So here is what a theoretical model will tell you. Now, theoretical model, is it good? Is it complete? Answer is no, because it's as complete as your first principles knowledge. Right? So you have data, you have first principles knowledge by themselves. The data has by itself veracity or uncertainty. By itself, the combustion system model has a sense of incompleteness. However, these two approximate or incomplete sources, the knowledge representation in them, you need to be able to bring together so that you eventually come up with an improved understanding of what's happening in the furnace. Use that in a framework which we call as an advanced optimization and control framework. What does that do? That basically does the following. It looks at all of this data, makes this combustion system model as current as possible with respect to the actual plant, so that this becomes what is now called in industry parlance as a digital twin. A digital twin is nothing but a model that best mimics the operation as closely as possible. You can say, I mean, can't exactly mimic it, but at least it will be able to, it can be a realistic replica of what's happening in the plant. And then these tools basically query the system model, look at the benchmark first, query the system model, go after the bad actors and find out what is the best way to push the benchmark as high as possible so that we essentially come up with a high efficiency combustion. Right? So here is the power of data, power of physics to the combustion system model that you bring together to constitute what I would then call as an augmented intelligence. What is augmented here? Data, the knowledge in the data, the knowledge in the first principles model, the physics, or physics understanding, both by themselves are not complete, or they are uncertain as far as the data is concerned, uncertain as far as the modeling is concerned. Bring what the best you know from both of these sources together and come up with an approach that essentially promotes a high efficiency combustion. Okay. Now, in terms of the technology maturity here, it is nowhere close to implementation, although there are some industries that are actually looking at, taking measurements of the flame through a camera, be able to determine what can be done in terms of design changes, in terms of operational changes and the like. Slowly beginning to happen, but there is substantial work that can be done here to be able to fuse information from all of the sensors and the system model to be able to come up with a high efficiency combustion. Okay, so this is a motivating example that I wanted to bring in to basically tell you about, how you can look at the AI and ML in a slightly different context than what the industry is doing, So I take you to this example just to reinforce that, what we are looking at right now is a digital tsunami. What does that mean? Data is coming at you at a pace that is much, much more fearful, much, much more difficult than what you can handle. You need quite a bit of experience in being able to process that information. What you see here is a trainee who is operating a fire hose, aflame, is being monitored by an expert who has handled this, done this, And really what you want to be able to do is, so this is the, instead of water, now you have bits and bytes of data. What you really want to do is, you want to come up with very advanced computing tools that will help you to leverage this data and be able to make smarter decisions. Okay. There is a very close context to AI and ML, because where does AI and ML, one of the sources we talked about is data. Where does it generate that information in that data? Where does it come from? That comes from digitalization. And again, there is a drive towards digitalization. So all of you might already be knowing what is digitalization. Digitalization is basically looking at converting what you consider as analog to a form that is transmittable, be able to process in a computer and the like. So you digitize, you digitalize. There has been a tremendous growth again there because there are advances in computing, science, sensing, miniaturing sensors, communications, embedded communication ability in the sensors, and of course, platform that can handle a huge amount of data. And with this digitalization, you have several benefits. For example, you have a very, very important aspect of being connected. I don't think I need to emphasize that point anymore, given that all of us on WhatsApp and various other social media platforms, the kind of connectedness we have with our family is something that underscores this point. Integration. In industrial practices, it's very important to integrate information from various sensors. Based on this, you basically have, first of all, improved safety, advanced prognostics, be able to predict when something is likely to go wrong, be able to predict an aberrant operation. So safety, productivity, both of which lead into something that's measured in industry as operational. Thank you.
Participants,
Kindly
please unmute.
mute your mics.
Thank you. So now this digitalization by itself leads to an area called Internet of Things. Again, all of you might have heard this as a buzzword, Internet of Things, but also Industrial Internet of Things. But now they also call it as IoE, which is Internet of Everything. Okay, so I'll just spend some time on the preliminaries and on how IIoT, the Industrial Internet of Things, is related to digitalization. Excuse me. All of this primarily leading to operational excellence, because there is all of this connectedness, integration that brings in the ability to handle huge amounts of data, and to be able to proliferate the power of these tools, you need to e-modernize the workflow and thereby usher in new ways of achieving operational excellence. Okay, I'll talk very, very briefly about these two aspects. I'll go to AI and big data, context in the industrial practices, look at a few scenarios, and then summarize in that I have. So let's first look at what is digitalization. Now, digitalization is a business transformation. And I know all of us on this platform are academicians. And being academicians, the word business might throw you off. No, what I mean is business is basically, it could be an academic activity, it could be an industrial activity, it could be many others. But it's basically a transformation of those. Okay? Transformation of conventional or partially digitalized approaches and vastly impact industrial practices to overall provide an improvement in the business performance. Okay? This transformation also, as I said, let's have examples here. cooperative decision making. Leads to regulatory clarity. Yes, request you to please mute the mics.
Participants, please mute yourself.
Or the host can handle the. Yes, from the desktop of Chaitra, you can kindly mute please.
I request all
I'm sorry, there is
participants
a
to
lot of
please
disturbance.
mute your
We are not
mics.
able to speak. Can the host please mute the speaker, name include the source, if it's from Chaitra's desktop? Okay, if all of you can hear, I think where this happens, let's just continue. So where does science and technology come in? Science and technology primarily comes in because the data has to be generated. So where do you locate sensors? What kind of sensors do you locate? How do you make those decisions? Then once you generate the data, transformation of the data, analysis of the data, and base that will make agile and optimized decisions. So this is the 4 Ds that I was talking about: digitize, digitalize, decision making, actually sorry, the background is not quite making sense. Okay. Okay, what is core digitalization? Advances in sensing technology. I talked about sensors becoming miniature. I talked about their ability to communicate, calibrate themselves, have low cost. So advances in sensing technology has contributed to all of this. For example, in a recent industrial application of a white film evaporator, we were able to miniaturize temperature sensors to such a small size and embed in it communication ability so that it was able to be at a point of action where the heat transfer is taking place, the evaporation is taking place, and communicate what is the temperature and related conditions there. So now those are all of these are now increasingly possible. Networking and communication, rise of 5G that requires real-time analysis, low power consumption of course, and also reliability of the sensors. Computational advances. There are powerful algorithms for distributed. Sorry, I'm sorry, this is quite disturbing. Can somebody please communicate and make sure that this is minimized? I'm sorry, I'm unable to proceed further till the noise source is stopped. Can somebody please mute the noise source? Okay, computational advances. We talked of powerful algorithms, optimization and control. Also in machine learning and artificial intelligence, we talked about the 4 V's of data analysis, and then the 4 ways by which we basically develop the analytics and deploy them: descriptive analytics, diagnostic analysis, analytics, predictive analytics, and prescriptive analytics. And finally, the platform, the biggest of them all, which is the IoT operating system, nowadays specifically dedicated IoTs operating systems, cloud architectures, uh, decentralized. We talked about architectures that are edge computing, uh, cloud computing, and the like. Decentralized and in a manner that allows for distributed computing. Of course, blockchain to ensure security of the data, which is now increasingly a concern. Actually, I think the host needs to speak. Is he just told? Can somebody please help me in this matter? There is some noise source that is. No, I can't pinpoint where is that noise source. But there is just too much of noise here, and I'm unable to.
Sir, hope it is clear now.
Yes, thank you very much.
Sorry for the disturbance, sir.
Sorry. Yeah. So I'll go ahead here. So all of this digitalization has gone into Internet of Things, leading to industrial Internet of Things, Industry 4.0, but we are also talking about a wish list for Industry 5.0 and Industry 6.0. Now, what is IIoT? Now, IIoT is basically a network or a framework of intelligent and highly connected industrial components. Okay. This primarily is designed to achieve benchmark performance, again, re-emphasizing those four aspects, provides elevated safety levels, data security, all of this, I already talked about it, but basically now this is a protocol. Okay? It's a protocol of how we need to connect all of these. Industry 4.0 defines these protocols, but brings in an importance of lean and efficient operation. And we are looking at advancing from 4.0 to 5.0 and 6.0, which brings in a massive personalization aspects in cyber physical systems. CPS stands for cyber physical systems. As you can see here, a human arm and a robo arm coming close to each other. Okay. Again, I've talked enough about IIoT. I'll not much about this, but basically all of this is oriented towards operational excellence, and it is already playing an important role in our lives. For example, if you look at this small cartoon over here, it says that I think my next smoke alarm is going off because Google AdWords just fetched me a fire extinguisher and an offer for a temporary housing. So, this person's home, there is a smoke alarm, and based on the network of sensors there, it is already predicting that there is likelihood of a house going on fire, and it has started to post advertisements to this person saying that there is a temporary housing available and there is a new fire extinguisher that you can buy. Not far-fetched, as you all know. When we do browsing on our Google on the site, you'll see all those AdWords and the prompting of, for example, if you're booking a travel, it will already show you what is the options for hotel at the destination and the like. So it's not very far-fetched, but increasingly the connectedness has a lot of benefits. Some with disadvantages are there in terms of loss of security and privacy, but nevertheless, this is there to stay and largely to our benefit. Okay. In the context of oil and gas, which I will talk about in a short while, there is a IEA report which talks about how digital technologies could decrease production costs to this extent, and provide substantial value in terms of recoverable oil improvement in terms of 5% globally. Okay. So this is something that is important, increasingly important, and all of us should basically get into this. Let me just switch slides here, because what I would do is I'll first take up case studies and then I'll come back to how these case studies actually help in this context. So let me take some case studies in the context of oil and gas, okay, and focus on operational excellence in the oil and gas context. Okay. Now, if you look at chemical engineering, a significant amount of activity is goes towards manufacturing, and in terms of scale, the oil and gas industry still continues to dominate the kind of curriculum that we have, the kind of understanding we need to develop. But going further, oil and gas impacts our energy scenario, and the energy scenario also in terms of renewables, solar, and the like is also growing. So it's a good idea to look at what is the power of the connectedness and the advancements in IoT and IIoT that would help in achieving this. Let's look at the oil and gas value chain. We have exploration, then this is what you would call as the gas value chain, production of the gas, processing of the gas, transportation and marketing. On the other hand, the oil, production again, transportation, and then the downstream retail and marketing, refining and marketing. This is something that's typically the oil, the two parallel oil and gas gas value chains. If you look at the timescales of decision making, and I deliberately bring this here primarily to emphasize what is the variety of data that you might encounter in chemical engineering. You have, for example, plants, wells, and facilities which essentially require decisions at a much, much faster scale than, for example, your production targets here. So you have at the lowermost level, the kind of decision making is coordinated control. What does that mean? Some of you have been to oil and gas platforms. There is basically a huge on a platform, a huge number of wells and several such platforms, each of them producing gas, methane, primarily natural gas, but also along with it a lot of other impurities. And you want to basically produce gas at the right quality, right pressure, right flow. Okay? Not all of these platforms will deliver such a gas for you. So there is a variety of parameters associated with the gas quality. You want to bring this upstream. To be able to do this, you want to coordinate amongst different platforms, different wells at the local scales. That is coordinated control. Okay? Then comes the aspect of optimizing production. What does that mean? Okay, look at the oil context. You want to make sure that the several hundreds, if not thousands of electrical submersible pumps that you put underground to pull out the oil, those basically function in a very reliable manner because it's a very harsh environment out there. Now, monitoring the health of the equipment, being able to predict when in its mean time between failure, where it is and when it is likely to fail, and be able to make decisions on should I take a pump for overhauling now or should I flog it over the rest of its time, useful time before I overhaul. It will depend on what kind of targets, production targets I have. So I need to make decisions here about based on the health. So this basically combines the power of data, the equipment health monitoring, with the power of optimization tools to optimize the production. Now the gas gets generated from a reservoir that is out there. Its characteristics change very, very slowly over years. Not months, but years. This is typically over months. This is typically over minutes. We look at monitoring the reservoir, surveillance of the reservoir, what kind of water injection systems do you need to have, flooding systems you need to have to enhance the recovery. And then you have a recovery plan. So if you look at all of this decision making as I go from bottom to top, there is basically a kind of a time scale and data gets generated in huge amounts. If you go at this minute scale and measure what kind of data gets generated over here, it's basically a fairly huge amount of data, and you want to be able to aggregate, process the data so that it reveals appropriate decisions at each of these levels. Okay? This is just an illustration of that when you talk of real-time reservoir management, mathematical modeling. Have anyone of you thought about modeling from first principles a reservoir? It's just gigantic, mind-boggling kind of activity. Solving that in real time is virtually impossible, but it's not necessary also because the dynamics change relatively slowly. There are a lot of data, 3D data, seismic over time. Okay, 4D is basically 3D over time, seismic data. You have a lot of operating production data. You also can do some geo modeling, which is what I talked about here. And now, based on all of this, you want to make decisions on what is the best well target, more at the operational scale. Going back here, all of this modeling is basically done to set targets onto the local level. How in the world would you process these huge amounts of data and be able to make local decisions? The only way this is possible is to decentralize distributor computing and make sure that while each of these local units make optimized decisions, they have a global perspective in mind, which means think globally and act locally. Okay? This is, on the other hand, the natural gas value chain. Nowadays, there is shale, there is also sweet gas, sour gas, there is also associated gas, there is mid-scale, depending on how much gas is present in the reservoir. You want to bring all of this together and eventually transport it. There is a lot of advanced decision making related to the production, related to the gas cleaning, related to the transportation. I mean, if you look at this entire enterprise-wide problem for a company like ONGC in India, for example, or for example, Shell or ExxonMobil or any of these other companies, there is so much of data across scale that needs to be integrated together to provide decisions on what, at the point of action, what needs to be done. And that's not, as you can imagine, a straightforward exercise. It just needs to be able to structure the data in an appropriate form, structure the decision making in appropriate form so that you can deliver the decisions at the point of action. Okay? So this is basically operational excellence. Develop and deploy improved and coordinated production practices. Improved, all of us know. Coordination, this is where IIoT, digitalization, and advanced decision making play a role. Coordination essentially means that you want to make sure each one understands what the other is doing and they act in a coordinated manner. Improvement indices are maximizing revenue from products, minimizing costs, meeting constraints, accommodating unscheduled events, disturbances, reduced downtime of assets. I talked to you about the pumps, for the oil production and the like, the others, and so on. So if you look at all of this, you basically have, to this illustration slide, what you have on an enterprise-wide level is a whole bunch of customers for the oil and gas that can ask for oil and gas of differing qualities. For example, if there is an LNG plant, and this is something I illustrate by this different color, the LNG plant requires highly pure gas. Whereas, let's say if I'm going to operate a gas turbine or a power plant, it can do with relatively higher levels of CO2. If I go to a fertilizer plant, maybe different levels. Now the volumes, the flow, all of this need to be coordinated. So I have a production delivery here. If I want to meet the production delivery, I have all of these assets, data gets generated, decisions need to be made in such a way that all of these assets work in a coordinated manner. You can see this symbol for coordination with the workflow, the people who essentially enable this. So now I want to emphasize this important point. No matter what you do with AI and ML, no matter the best of the AI ML algorithms, unless you put those into workflow involving people who are the enablers, the success of that is not guaranteed. You want to make sure that all of this happens so that you are able to meet these production targets in the oil and gas context. Okay. I'll skip this maybe in the interest of time. I'll directly go to this. What does operational excellence essentially mean? For example, on one scale of excellence, let's say productivity, other scale is specific energy. What I want to do is I want to do this. I want to be here. Okay. Now, how do I establish this? I look at the archive of data. I mine the data. I determine when the operation has been productivity-wise very high, energy-wise very low, and classify all those data points as best. Then I have average and I have good. Okay. What I would like to do is basically establish this as a benchmark, exploit process understanding, possibly with redefining the benchmark, look at current data, see where it is, whether it's average and good. And what I want to be able to do is push it as close to the best as possible so that when I began, suppose I had this kind of a distribution of the overall quality, what I want to be able to do is push it northwest, more towards stretching the benchmark so that I narrow down this variation. This is the new scenario, and I go closer to the product quality. Okay, this is what operational excellence is all about. Narrowing down variation, going as close to the constraint as possible. All of that is facilitated by exploiting the power of tools and first principles knowledge so that you are able to consistently improve your benchmark and push the current operation as close to the benchmark as possible. Right? Re-establishing the benchmark essentially means, you are going closer and closer to the theoretical benchmark, which is this red line. How do you go? Is this theoretical benchmark reachable? Perhaps not. Okay? But it's a good benchmark to have because you can never exceed it. And that is where you want to push all your operation relative to this so that you are making sure that in terms of continuous improvement, you are continuously acting and pushing the operation northwestwards for this application. Okay. So the overall idea of operational excellence, operational optimization, of course, that is bringing together data and models, okay, transforming knowledge into decision advisories, and then of course also an automated workflow, eliminating manual interfaces, propagating this towards improving, making smarter and improved decisions. Okay. So essentially what it means is operational optimization in the context of big data analytics, bringing in the power of data and digital twins. So you decide on performance metrics, both on the individual assets in the oil and gas, overall enterprise. Individual assets help in coordination, overall enterprise brings in cooperation, which essentially together make sure that you think globally but act locally. Establish benchmarks for these metrics, theoretical based on digital twins, practical based on operating data, and then continuous efforts to basically drive the operation closer to the benchmarks through coordination and cooperative decision making, exploiting modeling knowledge, and redefining your benchmark. Okay. Let me just take a few examples here before I come back to these slides. Let me just go to these case studies. Okay. And then I'll come back to theoretical, because normally, it's a good idea to first emphasize the impact and then tell you how do you reach that impact. Okay. Now here is one example of the upstream oil and gas delivering gas to the downstream. What LNG stands for is liquefied natural gas. Okay. So on the upstream, you have reservoirs and wells. Reservoirs basically are the ones where the huge amount of oil and gas is stored. Wells you produce. Wells are basically something like you stick into the reservoirs like you do in a Coke, can of Coke. You stick in a straw. Those are the wells. Then you have facilities. The wells produce into facilities. Facilities then produce into the pipelines, and then there's an enterprise boundary, and then you deliver to the LNG. Now, as I said, and I think I have an illustrative example here. This is a simplified gas schematic. You see that there is one production asset platform called A1, second one A2, a third one that's A3, and maybe a future one that is, let's say, A5. There's also an A4. So A1, A2, A3, A4 are these production assets. They produce oil and gas at various volumes, pressures, and quality. You want to be able to compress this gas whenever necessary, use them if they are already at high pressure, and then blend them in such a way that when you deliver to the LNG plant, you are basically trying to preserve the sweet gas. Just minimize this. You basically want to preserve the sweet gas. So that's where the blending comes in. So you see here, one of them is a high CO2 line, one of them is a low CO2 line. You want to make sure that you use as much as possible of the high CO2. You want to preserve the sweet gas, which is the low CO2, and make decisions in such a way that you deliver clean gas as per norms to this LNG facility. That requires us to coordinate between wells across platforms or assets. Okay, and you want to make sure that you produce the gas at the right quality, volume, and pressure, and then blend it so that you are able to meet that quality. That's the first example of coordination. Okay. The second example that I want to talk to you about is within this LNG plant itself. Within this liquefaction LNG plant itself, the gas comes in here. There is a slug catcher. There is an acid gas removal. There is a mercury stripping unit, NGL extraction, liquefaction. There is an end flash. So all of this is basically within the cold box, as they call it. And then there is a fuel gas system that basically powers this cold box. And then there is the shipping and logistics. Now, in terms of the size of this problem, even within an LNG plant, it is quite gigantic. Okay, data generated, the kind of units that need to be monitored, and so on. So you have optimizers that balance the input gas. There are optimizers that balance the energy, and there are optimizers that balance the shipping and logistics. Because anything that happens here propagates back here. Okay. For example, if you are not able to pick up the gas, you need to reduce production. You need to reduce the intake of gas, and that has a domino effect on the production of the gas. Okay. So you need to be careful here in terms of the decision making, and that's where these optimizers play a role. For example, optimizer A looks at the upstream part of it. Optimizer B looks at the fuel system of it. Optimizer C looks at the distribution logistics, and integration of all of this reduce. In fact, when we did this simulation study, it resulted in reduced fuel gas consumption the fuel gas system, reduced flaring of excess gas, that they are able to not flare them, but basically transform all of that into value, and also extended life of cryogenics, because we want to make sure that the health of the cryogenics is high. This is a third case study, which is basically leveraging the power of data to monitor controllers themselves. This example is from a kerosene hydrotating unit at Suncor Energy in Canada. One of my students was looking at this problem. MPC stands here for Model Predictive Control. So you have 3 manipulated variables, 7 controlled variables, and some disturbance variables. Now, those of you who have worked in the model predictive control area, you might easily be able to realize that the success of any model predictive control algorithm depends on the model. Centrally, it is the model that plays a key role in what kind of controllers, control efficiencies you can get. And this work, although it had an MPC on the kerosene hydrotating unit, there was severe performance degradation. And therefore, the MPC service factor, which means how much time the MPC works and has the confidence of the operators, was pretty low, only about 10%. Okay? And so the student actually got the opportunity to analyze the data and look at trying to identify where the mismatch was. He used some tools associated with machine learning to be able to do that. Here is the schematic. There are very poor quality models for CV2, CV4, frequent limit violations on the constraints that was observed. And this is primarily to show you one of the tools called partial correlations approach, which actually was able to isolate channels with where there was a mismatch, which when corrected, substantially improved the service time of the model predictive controller. Okay, so this is like monitoring the doctor. The doctor is the controller here. The controller basically keeps or translates targets into decisions on the plant. However, there is somebody who has to monitor the doctor itself, which is the Internet of Systems, the method by which the loop was being monitored and the mismatch was corrected. Okay. So the fourth example that I want to take you through is something that I would think would come close to what we call as a digital twin, but not quite there. What did I say was a digital twin? A digital twin was basically a model that's as complete to the extent that we can develop. Okay. It also uses data to update the model, and then that model is queried to make optimized decisions. This, in some sense, was a digital twin, but I'll explain to you what were the shortcomings. Okay, the first application was a low-density polyethylene reactor. The work done in University of Alberta again. This was basically polymerization of ethylene to polyethylene. These are the temperature pressure conditions. While this is a desirable reaction, there are several undesirable reactions, potentially hazardous. For example, ethylene getting converted to carbon and hydrogen, which is both loss of economic loss as well as potential explosion. Ethylene getting converted to methane and hydrogen. These are undesirable reactions which can lead to potential explosion. So you want to make sure that these reactions do not take place. Okay? However, those of you who have tried your hands at modeling a polymerization reaction know that it's not a simple exercise. So with this limited objective monitoring the LDPE reactor, here was, oh, I'm so sorry, I didn't put those equations. Maybe I'll just shift between the slides to be able to show you that application. See if I can directly go there. Yeah. So basically, this was the reactor schematic, okay, where there are several flows, and there is also the product flows, the initiators and the like, and also one can write, because you want to monitor the potential explosion, you want to write an energy balance. So when you write the energy balance, you have the heating term because of the heats of reaction. You have the enthalpy leaving, you have the enthalpy coming in, okay? And at a steady state, condition, you want this to close. And so this must be equal to 0, or this is the error. So the simple approach would be to just monitor this error and make sure that everything is fine using the model. But there are several uncertainties in the model. For instance, the way the specific heat is dependent on temperature was uncertain. Likewise, several aberrant operations can happen. And so all this, uncertainty. So you open up this equation now and quantify the uncertain terms. So if you open up that equation, you have all of this. And now what you do is you basically lump together the uncertain terms and the ones for which there are measurements, for example, temperature and the like. And you write a simpler equation here where the alphas contain the uncertainties and the h's contain the measurements. Okay? And now you monitor this relative to the data that you get. So you do something called principal components analysis on this. And when you do that, you essentially get thresholds for safe operation. And when this is violated, you have a danger of a decomposition. And this was a simulation exercise where energy balance closure was monitored. And about 3 minutes before the onset of decomposition, it was possible to predict that there was this explosive reaction that's likely, and the reactor was closed, okay, or shut down. Right? So this is an example of, to some extent, you're leveraging the physics in terms of an energy balance. You're also exploiting the data, and you're making these decisions. Okay. So, so let me just pause here because I just want to make sure that what I'm talking makes sense before I start delving into the theoretical aspects. Let me just stop the slide sharing and pause for any questions. Any questions up to this point, please? Come on, all of you are faculty colleagues, and all of you know the importance of asking questions. It will help in terms of being able to pitch the material well to you. So please ask questions. Hello. Students, faculty, colleagues, any questions up to this point? Okay, I just want even one trivial question just to know that I'm being heard. Nobody? Come on. I mean, I'm both flattered as well as surprised. Flattered because I think whatever I have spoken has made a lot of sense. Also a little apprehensive because I know that is not the case. So, any questions, please? Yes, Nabil wants to ask a question, but he needs to be unmuted. Can the host unmute? Oh, I'm the host, so maybe I'll unmute. Okay, Nabil, please go ahead. Okay, let me see. Yeah, I have sent the request to unmute.
Yeah, yes, sir.
Yeah.
Yeah, it was nice hearing you and nice meeting you after some time. Good. It was really an interesting overview. But I have a question on integrating physics with machine learning model. What do you think are the challenges?
The challenges in making a digital twin, for example. So, while I hope you agree that this is where we need to go towards as a desirable state, that we want to have integrate both the knowledge from data as well as models. Okay. But the difficulty is in being able to do that, understanding basically the uncertainty present in the data. Modeling we probably can understand to some extent, but uncertainty present in the data, removal of noise, basically making sure that the data is of a quality that is right for updating the model. That's number one. Second question is second aspect is being able to do this in real time. Can we really do it in real time? Advancing in computing infrastructure perhaps can help us do that, maybe through parallel computing, maybe having dedicated platforms. appropriate judicious distribution of tasks between edge and cloud computing and the like. But really, it depends also on the application. For example, in the combustion application, while there is a lot of rigorous models that model the combustion reactions, the flame, and the like, some of the work done in MIT, Anuradha and Swami's group and the like, with the model flame instabilities and the like. Nevertheless, that model is still a model. There are some parameters in the model that need to be updated with data. Okay, depends on what is the combustion source, the medium. If you're making carbon black, there is a certain type of fuel oil. If you're making steam, then there is a certain other quality of fuel oil, right? Precursors that need to be added to the oil determine the combustion characteristics. You need to be able to tune that combustion model to the variety of applications. So, the rigor of the model, the appropriateness of the model is another challenge. And how can you update that in real time? We would certainly like to do this, but these are some of the initial challenges. It's application specific, I would say.
Yeah, thank you, sir. Thank you. Yeah.
Okay. Any other questions? Very quickly, one more before you can just either raise your hands or just type in the chat box. One other question, please? Anybody? I see. Any other questions? Okay, no. Okay, all right. So let me just go ahead then.
Sir?
Let me continue. Yeah, anybody? Just heard a whisper. Anybody would like to ask just one more question before we go into
Sir, they have put questions in chat box, sir.
Yes, there is the question.
How do we apply in IoT in refinery process?
Oh,
Question
Internet of Things and refinery processes. Okay, what is Internet of Things? Understand that in day-to-day life versus in industry, okay, the security of the data and the security, the integrity of the communication systems needs to be a lot more rigorous in the industrial practices. Okay, and therefore IoT gets transformed into industrial IoT. So I'll just rephrase our question as IIoT rather than IoT. Okay, and now the question here is in refinery processes. There are several places where optimized decisions are currently being met. Okay, are being made rather. But there is now, we'll talk to IOCL, BPCL, HPCL, there is a drive towards the first step, precursor for IIoT, which is digitalization. You first want to make sure that you have digitalized your process to a much, much larger extent or degree than what it is right now, because you want to be able to, if you really want to make coordinated and integrated decision making, you need to have the right sensors at the right place that communicate at the right frequency that gets accumulated onto the platforms and be able to make those decisions. Okay. The first thing is to be able to digitalize. And then along with that, you want to bring in the power of machine learning, AI, and first principles knowledge. So first principles knowledge-based decision making is already being done in the industry through the use of advanced simulation optimization platforms like Aspen. But their translation via model predictive controllers onto the field units has been good, but not as good as it should be. And coordinated decision making is extremely slow because they've still not realized the benefits of all of this. So IIoT, what you would be able to do is make sure that at the unit level, for example, you take a fluidized catalytic cracking unit. It contains a reactor, contains a regenerator, it contains a gas plant. Now, even this complex of FCCU basically needs a lot of coordination because there is a recycle. What happens in the reactor impacts the operation of the regenerator and vice versa. Likewise, the quality of the gas that goes to the gas plant. Okay. So each of these units you can try to optimize, achieve performance excellence in an integrated manner through a centralized system. But that will be a gigantic exercise because the kind of data that's been generated is huge. So you want to distribute and you want to coordinate. Now here is where IIoT can come useful. At the individual unit level, the reactor level, the regenerator level, the gas plant level, you can look at decision making. You can look at integrating the decision making in such a way that the overall cracking in a fluidized catalytic cracking unit, there is cracking happening of a crude into different constitutive units. You want to be able to optimize it in such a way that they are able to meet the target. And this coordination is possible. It's being done to some extent now, but it's, you talk to any petroleum refiner, he'll say FCCU is the biggest challenge. Okay? Models are a problem. How do you do those decisions in real time is a problem. The coordination becomes substantially improved if you have IIoT and an opportunity to be able to coordinate the decision making. Okay? Go further to, let's say, the downstream. The upstream and the downstream, I already showed you that in the context of an LNG downstream and the exploration and production upstream. There is a coordination between them. Even within a refinery, upstream and downstream, there are opportunities for integrated decision making. And all of this become facilitated by IIoT combined with first principles physics and optimization and control decisions. Okay? I hope I've been able to answer that question to you, Sasikala. Yeah. Okay. Are there any other questions? Okay. Now let me just, in the interest of time, go back to my presentation and continue for about 20 minutes and then pause again. For some reason, I'm not able to share my slides. Can you please make me the host? I'm not able to share my slides here.
Sir, 2 minutes, sir. We'll check.
Yeah. The share button seems to be disabled for me, so you have to make me the host again. Okay, so while I talk, while this is happening, let me continue. What else? Yeah, I think I can share the slides now. Yeah. So let me go back to my presentation. Yeah, we talked about this, and yeah, I'll come back to this summarizing remarks a little later. But let me get into a little bit of details and talk to you about how do you combine this. Okay. So some of this I have presented earlier in one of the related talks. But basically, what we are talking about is AI and ML, which is purposeful and discovery and purposeful utilization of meaningful patterns in the data. In process control, this is regularly being done, but the new generation paradigms basically look at distilling it in this form. Basically, what you have is data as discrete elements based on which you get a raw pulse of the system. When you aggregate the data, you get signatures and trends. When you organize information, you get knowledge, which is best operation templates. When you apply this, you get consistency in best practices. Okay? Based on all of this, you want to be able to delve into the data and try to get a sense of what's happening there. Where are we right now in the AI area? We are somewhere I have talked to various extents on the different bullet points here. So I will not re-emphasize this, but we are somewhere in the exabytes area, which is here. Okay. Typical chemical manufacturing runs into the exabytes area, where somewhere here. And you want to be able to, in terms of volume, be able to delve into this archive and make sense of what is in there so that it will assist you in your decision making. I want to just pause here because most of the time I've been talking about manufacturing, but it's also useful in the discovery and development. For example, what you're doing at the lab scale, pilot scale, plant scale. We basically applied this in the context of a pharma product life cycle, where the discovery happens at the lab scale. It gets and also some amount of lab scale studies happen, data is generated, process understanding built, goes to the pilot scale where there is a scale up to see whether the same yields and expected purities are achieved. Then it goes to the full plant scale, and you want to be able to integrate the data across the scales and carry it further. Similar things happens in catalysts and a whole bunch of other new processes that we do. So, in terms of the theory, at least in chemical engineering, but not limited to that, what we are right now is, in our understanding of AI, we are in this last box where the model uncertainty is high and is poorly known and the measurements are noisy. I would rather say that we are just being choosy in treading the simpler path where we just focus on measurements. The path of bringing in the model, refining the model is a little laborious, and I think we need to embark on that if we really have to, leverage the full power of these tools. As I said, we had models, measurements, and an extent of how accurate the model is, how uncertain the measurements are. We have some understanding of that. So depending on that, here are the spectrum of tools that are or research that has been done in chemical engineering. If you have accurate models, noisy measurements, you will have a data reconciliation problem. Noisy model, noisy measurements, estimation and filtering. I think Dr. Nabil was involved in a very exciting project with us on one of the industry applications. Model is partially known, measurements are noisy. You go in for leveraging the best known physics to gray box and then adapt the model. And when the model uncertainty is high, this is our understanding of AI. But when you are able to bring all of this into this, it indeed becomes AI recoined as augmented intelligence. Okay? Here are some typical objectives of AI and analytics. You certainly want to do dimensionality reduction, a very, very mature area using principal components, but it's advanced variants. Okay? There is a lot of research being done, and this is of direct importance to the industry when you're looking at it only from leveraging the data aspect of it. Okay? It reveals what is the correlation among different variables. It helps you to do prognostics, diagnostics. Going further, discover patterns and clusters in the data to establish which is a normal operation, aberrant operation, even within normal operation, which is a superior operation, average operation, inferior operation. Those kind of classification can be done. Soft sensors, if you cannot measure, especially in the chemical engineering context, you can never measure the variable that's of direct interest to you. Never meaning compositions. You cannot measure it at a rate as frequently as you want. So you build soft sensors to be able to do this, right? So that's something that you want to use AI and ML approaches. Closed loop control through estimation and filtering, you can generate reduced variance estimates, generate predictive models for prognostics. You already saw the application of the FDP reactor. You could do continuous performance assessment to drive the operation as close to the benchmark, but also advance the benchmark unless you are sure that you have hit the theoretical limit. You can advance the benchmark as well. Right? So all of these are possible in AI and analytics. Skip this, as talked about this in different forms. I'll just directly go to knowledge representation here. So this is really that slide on knowledge representation. A white box model where I have first principles knowledge. I use data only to update the constitutive relationships, and I have a white box model. If I don't have a complete first principles knowledge, I have a partial first principles knowledge, and I have data. I represent what I know about the physics. I use the data to adapt, and I have something called as a gray box model. If I have no first principles knowledge, or if I would say if I choose not to use any first principles knowledge and just rely on data, then I get what's called as a black box model. I would urge that we should shun this approach and go increasingly towards this, because that improves the quality of our decision making. Okay? I mentioned already about this, the different kinds of representative problems, data reconciliation problem. Let me directly go and look at the slides. The need for data reconciliation. Those of you who are not aware of this, basically it's an approach where you accept the fact that your measurements are noisy, can have outliers, but they need to respect the basic aspect of the process, which is mass, energy, and momentum balance. And if you can write those, then you can reconcile the raw measurements to the process model in terms of the mass, momentum, and energy balances, and get a set of reconciled measurements Very powerful tool in the industry, used quite extensively, for example, in custody transfer, where, when a upstream oil and gas sells it to the downstream, there is always a conflict between the meters. How do you reconcile the readings of the meters to be able to determine the appropriate amount of gas or oil that has been transferred? Instrument maintenance, real-time process optimization, determining the base case from which you can improve. How do you determine what is that base case? That's where data reconciliation becomes quite important. Data compression problem, you want to reveal the lower dimension space. A very, very simple example of this is, in the same furnace application, I have fuel flow and steam demand as measurements. If I choose to look at them in a univariate sense, I have control limits on each of them, and these are the data points with respect to time. If I look at it in a univariate way, I might not be able to detect this abnormal data because they fall within the control limits. Okay, but if I look at it in terms of monitoring the correlation between them, which is what I show here, then I'm able to show this because these points fall outside these thresholds. Whereas in the earlier slide, these two points fell within the threshold of both the steam demand and the fuel flow. So there is a merit to revealing the lower dimension space. In the simple example, the higher dimension space is 2. We have lowered it down to only 1, and this gives you a clearer picture of what's happening below. PCA is tremendously powerful. We saw this example already of the LDPE reactor where PCA was used in the context of a LDPE reactor along with the model. Okay. Data clustering problem. Skip these initial aspects of it. But basically what you want to do in clustering is organizing the data into object into groups whose members behave in a similar way. For example, in chemical engineering, when we do regression on nonlinear plants, you want to be able to classify the data points that obey the same, perhaps linear correlation. FDD, look at data points that represent normal and discriminate abnormal operation. In systems biology, for example, you want to identify genes that are responsible for specific regulatory functions. Identification, similar to regression, look at regions of linear operation. Okay. I'll skip this in the interest of time. What I'll do is I'll basically get into different clustering methods. There are hierarchical as well as the algorithmic approaches to clustering, and I'll just illustrate to you one aspect of clustering. For example, what you see here is 2 clusters of data points. One is red in color, one is blue in color, and in this original space you see that they belong like this. Okay, so a red cluster can get misclassified as a blue and vice versa. Okay, that's because of this overlap. What discrimination and cluster building does for you is to separate them now, transform the data into a new space where they get separated in this form. Now, if I have a blue point, it quite unambiguously gets classified as a blue and a red, right? Now, this is the advantage of being able to discriminate and talk about decision making of classification. Okay. So a second example here of advanced machine learning tools applied to cancer patients. Original data of the cancer patients is in this form. You see that there are significant overlaps, but when you do transform them into a new space, you see, for example, the pink points all aggregate together. The spread of the inverted triangles are more closer. So basically, it helps in discrimination and classification. Okay. In a high purity distillation column closer to what we chemical engineers do in control, there is a possibility that you can decompose the overall non-linearity into locally linear models. In this application, it was 4 linear models that gave you extremely good control even at extremely high purities. Okay. This is known to be a non-linear in nature. Okay. Likewise, in data regression, you can do Kalman filtering, advanced variants of that Kalman filtering that leverage the power of the model. Measurements, this is the Kalman filtering algorithm. To basically generate estimates of the measured states, unmeasured states, possibly some of the parameters and the like. Okay. Won't delve into this, but maybe you can read literature related to this. We also applied this to batch processes in the context of pharma applications, and we're able to reliably predict the quality. This is one application there where we are able to quantify the health of the batch as seen here, predict the final quality index in terms of the antibiotic titer, the run length and the like in real time for this batch application in pharma. One is also able to detect and diagnose some of the bad actors here that can contribute to potentially reduced productivity. One could do performance assessment, characterization. I'm just going fast here because I already talked about this. Assessment. Monitoring is to basically be able to say where you are related to the benchmark, and assessment is basically establishing that benchmark. And so that's what operational excellence is all about. I think I did spend time on this slide. So here is an application where for a nitric acid plant, a tighter temperature regulation through monitoring of the performance index. It was low here during this time, and the temperature variations were large. As we went towards the retuning, so that the performance index improved and resulted in a 22% increase in catalyst life. Likewise, model plant mismatch detection, I talked about this already, not spend time on this. Interaction and nonlinearity assessment, you want to be able to go into advanced tools that are beyond the normal statistics that is being taught in machine learning courses. Higher order statistics based metrics such as coherence, bicoherence, spectrum, bispectrum, they help you to detect nonlinearities. For example, here you can see ordinary data cannot detect the nonlinearities, but if you look at some nonlinear transformations and bicoherence plots, it indicates the presence of a nonlinearity. Okay. So this is really a quick overview. I think I'm going closer to the time. Let me just, this is one slide which maybe I talked about this FCCU, and I talked about this in some sense. I have be able to give you perspective of this. Again, I'll not spend too much time on this. I'll just close by saying that the engineering problems, some of the engineering problems for us chemical engineers are listed here in terms of combustion monitoring, environmental systems, looking at CO2 buildup sources, patient health monitoring, engine health monitoring, causality detection. A whole bunch of problems are there out in the industry. And I'll skip slides and come back to this summarizing remarks, where I can say that significant opportunities can be realized through digitalization and integration through AI and ML. It's very important to proliferate this decision making into the workflow. So that's what I said, integration of decision making with the workflow. And there are a lot of aspects that are important here, including AR, VR based familiarization and training. Generation of outcomes and aggregated metrics to assist decision making, continuous improvement through redefinition of targets. Okay. All of this is possible through integrating AI, ML, and digitalization on our manufacturing systems. And finally, for those of you who think that we have done enough in AI and ML, I have a benchmark that is potentially reachable or not, I don't know. Comfort control. Can IoT, IIoT, industry 4.0, 5.0, 6.0, 7.0, whatever you want, you can think about. But the benchmark is, can these systems mimic? That means sense and deliver the comfort of a mother's touch. This is a challenging problem that I will leave you with, and I will stop here because it's already closer to the time and I want to take some questions. So thank you very much, and thank you for your kind attention. Let us take some questions.
Thank you so much, sir. It was very informative session on digitalization, artificial intelligence, and machine learning. Exciting opportunities by Dr. Ravindra D. Gudi, sir. Now I would request participants to raise if any queries.
Yeah, please. I think I will get a performance assessment of my talk, if you will, based on what questions you can ask. I need that performance assessment to characterize my performance relative to a benchmark. So very, very important in terms of your questions.
Participants can raise your hands so that access will be given. Or you can put your questions in chat box.
Chat box, yeah. Hey, come on, please don't let me leave the talk assuming that my performance has been closer to 0 on a scale of 0 to 1. So you must ask questions. It can be very simple as well, doesn't matter. Please ask questions. Now, is there a infrastructure problem for them to ask questions? I mean, can you make, are they able to raise their hands, or I don't see a.
Sir, 1 second. We have a question from Dr. Chetan.
Chetan, yeah. Yeah, Dr. Chetan, if we can just enable him to ask the question. He's raised his hands.
So good morning. Good
Yeah,
morning.
yeah. Good morning, Dr. Chetan. Yes, please.
Yeah, it was a very nice talk, and that's we were looking at this particular topic. Okay. Sorry to others. I have not introduced myself. I am Dr. Chetan from BMS College of Engineering. Sir, the artificial intelligence. What all other topics? Actually, I missed your first 15 minutes of talk. I want to know what all things we need to look into with respect to artificial intelligence in the future. Is with respect to chemical engineering aspects.
Yeah. So, in the spectrum of what we do in chemical engineering, AI plays a role nowadays. I mean, it had, but now there are increasing opportunities. Right from the materials discovery, catalyst discovery, product discovery point of view, right up to the manufacturing and eventual distribution of the product. Okay, I spent most of my time on the manufacturing and operational aspects, but if you go down to aspects related to discovery, there are this approaches such as structure property relationships, quantitative, qualitative structure property relationships, structure activity relationships, lead compound optimization in drug discovery, drug development, and the like. Discovering green solvents, ionic liquids. All of these are such complex problems because the feasible candidates are very, very huge, and you want to screen down to a smaller set of candidates which you want to do experiments on and determine the final one. That involves a significant amount of classification, I would say, exploiting experimental data and also molecular simulations. The result of, molecular simulations you can do to a very, very rigorous degree. But how do you interpret the outcomes of a molecular simulation? We can combine that with machine learning to say, for instance, in protein structures, protein docking, and the like, you can make decisions on what would be a good protein structure that would be feasible to take further in terms of development and the like. So product discovery, AI and ML has been playing a very, very powerful role now. You can just, if you search the literature, one of my students is working on that right now. There is just an explosion of literature there on how you can look at materials database, molecular simulations to be able to come up with candidate molecules for newer applications and the like. Okay. So there is one. Then as you go, in one of my slides I mentioned about the product life cycle, starting from once you identify a molecule, learn to do experiments, learn to scale it up and manufacture. Optimizing this entire decision making in the life cycle is another very important value chain where AI and ML can play a role. So opportunities are just tremendous.
True.
We just
So,
need to look at how to
to
right
select
to
which is the right one is the biggest challenge. Now earlier it was a scarcity of material. Now it is
but let the application drive it. No? My suggestion would be let the application drive it and work backwards. For example, let's take the lignocellulosic application. You want to come up with a good solvent for dissolving lignin, let's say. Now look at the structure of the lignin, look at the structure of the Hansen solubility parameter. You want to maximize or come up with an ionic liquid that has a Hansen solubility parameter as close to that of lignin. What candidate molecules or groups can be brought together? Look at the predictions that are made through AI and ML, and then see what is the candidate ionic liquid that will help in this application. Likewise,
thank you, sir.
any other material.
Yeah, there are many. I have gone through the material. The literature is plenty. It's a very vast part. Yes, sir. Thank you very much, sir. Thank you very much.
Thank you. Let me get it.
Yeah.
Yeah. I
Sir,
see one
we
more
have
question
another
from
question
Shyamala.
from
How data
Shyamala.
science can be
Yes.
used to check water potability, minerals in RO water. Okay. See, water potability typically has both smaller intensity and larger intensity ramifications. The smaller intensity is, for instance, if you add chlorine in the water and you want to regulate the chlorine levels between 2 points, two values. If I add too little chlorine, there can be contamination in the distribution. If I add too high a chlorine, it will cause disinfection byproducts, and that's also harmful. At one level, that kind of a decision making has to be done. The second level of decision making is at the treatment step. The treatment step, what you talk about in terms of the presence of heavy metals, arsenic, fluoride, all of that become useful. And the problem, and we are working on one such project now, is that the problem there is that how do you have the right type of sensors that can deliver the quality of water at a frequent interval, okay, in terms of these heavy metals and the like. That becomes a critical problem at the water treatment plant. But your question is more towards RO. And in RO, what is good for health in terms of the mineral content is something that is similar to a problem of artificial nose. Artificial nose, if you have read about literature about artificial nose, it's able to check, for instance, the extent of decomposition in food material. Likewise, when you are talking of potable water and right mineral content to promote health of a human being, you want to have that right distribution, and there could be several combinations of those mineral content that can give you the same inferred reading. You want to find out the one that actually promotes the health. So it becomes a problem of classification and related things. Yeah? So again, AI and ML play a very powerful role in being able to discriminate between these scenarios and find out that RO quality or combination of minerals in RO water that will promote the health of the individual. I hope I've been able to answer your question. It was Shyamala. Dr. Shyamala, I have been able to answer your question. Thank you. Any other question? All right. I think we have gone beyond the time. It's been nice talking to all of you. Wonderful sharing my research with all of you, and happy to be able to discuss further whenever you would like to get in touch with me. Just feel free. And thanks to MVJ for this opportunity to connect with all.
Thank you, sir. It was really an informative session. You showed us, like, being a chemical engineer, our job is not only designing boilers and reactors. Moving forward, we can find excellence in applications of chemical engineering in emerging fields like artificial intelligence, data science, IoT, and machine learning, etc. And also, you have enlightened us about the emerging topics on sensor diversity and what is digitalization, importance of IoT, and how does it impact all these things. And I hope it was a better platform for understanding of the topics like operational excellence and different ways of achieving it with the help of case studies for better understanding. And also the data generation in a typical product lifestyle and sources of improved cause and effect relationships. It was really an informative session. Thank you, sir. On behalf of management of MVJCE and the Department of Chemical Engineering, I extend my very special thanks to you, sir, for your presence and giving us the most valuable inputs.
Thank you very much.
Thank you, sir.
Okay, take care, everybody. Just remember the last slide and see if we can stretch your research to be able to solve that problem, mimicking the special comfort control problem. Okay, bye. Take care.
Thank you, sir. Dear participants, the feedback link is shared in the chat box. The attendance will be traced based on the feedback link. I request all the participants to kindly fill it. The feedback link will be accessible till 5 p.m. today. And let's have a tea break, a short break for 30 minutes. So we will be joining back for the next session by sharp 11:30. Thank you all.
Dr. Manisha, am I audible?
Sir, just wait for some time, sir. Some technical issue.
Okay.
Augusta, ma'am.
Yes, ma'am. Now, sir, we will wait for like 2 minutes.
Okay.
Let participants join, sir. Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great. With the inspired quote by the missile man of India, Dr. APJ Abdul Kalam, I would like to start the session. I'm Augusta, Assistant Professor of Department of Chemical Engineering, MBJ College of Engineering. Good morning, everyone. Hearty welcome to all the participants who has joined for today's session 2 on the first day of 1 week online FDP program sponsored by AICTE Training and Learning on Data Science and Artificial Intelligence in Chemical Engineering, Recent Trends and Future Outlook. Organized by MBJ College of Engineering, Department of Chemical Engineering in association with IIC and IQAC. Now we have our most renowned person, Dr. Ashutosh Yadav, Assistant Professor of IIT Jammu with us. Let me brief some key credentials of his achievements. The professor has completed his post-graduation from IIT Delhi in the year 2012 and be awarded doctoral degree from IIT Delhi in 2018. He joined as Senior Research Scientist in the Corporate Research and Development Center of Bharat Petroleum Corporation Limited, Great Noida, in the year 2017. Apart from his academic and research experience, the professor has established his research interest in the area of machine learning, CRT, process optimization, and got a good publications in this area. The professor has 2 patents in catalytic hydroprocessing. Without further delay, I invite Dr. Ashutosh Yadav to deliver his talk on application of machine learning for multiphase reactors. We invite you, sir.
Okay, thank you, Dr. Augusta, for this kind welcome. So I'm sharing my screen. Is it visible?
Yes, sir, it is visible.
Okay, so first of all, I welcome all the participants for this AICT training and learning course, that is 1 week FDP. So, and I also like to acknowledge the college. So the topic of my presentation is application of machine learning for multi-phase reactors. So as all of us know that the basic idea of this FDP is data science and artificial intelligence in chemical engineering, recent trends and future outlook. So this is one area where machine learning as well as artificial intelligence is being used. And multi-phase reactors, as anyone who deals in chemical engineering will know that yes, reactors, they form the heart of any chemical engineering process. So that's where, and most of these chemical engineering reactors that we talk about, they are not just CSTR or PFR, because they being the ideal case, we deal in some sort of multi-phase reactors, like trickle bed reactor, bubble column reactors, and even in the case of boiling water reactor that is used for producing electricity. And so that is also an example of multi-phase reactors. So, and they are having a lot of application in industrial setup. So that's where this multi-phase reactor design and development of these multi-phase reactors, they require a lot of experiments as well as modeling and simulation. And in case of modeling and simulation, computational fluid dynamics plays a very vital role, as well as in case of during these experimental processes. So what happens that these experimental process as well as this computational fluid dynamics, now a lot of work has been done where machine learning is being used to expedite the process of experiments as well as expedite the process of computational fluid dynamics. So I will discuss about this. So first I will go and start with this industrial revolution. So this industrial revolution, right now we are in the era of industry revolution 4.0. So what happens that in industry 4.0, we are dealing majorly with cyber physical system, Internet of Things, networks, where one device is speaking to another device. And so many things are there. But the point is that we started from industry 1.0, where machinization, steam, power, weaving, loom, all these things that came into picture. Then once we established these industries and all, what the thought process was that how to increase that production to a mass level. Because as we keep on increasing our capabilities, mass production, assembly line, electricity, electrical energy were being used in industry 2.0. Then came the industry 3.0, where automation, computers and electronics, they come in big way. But the point is, once we started to have application of computers and our computational power, our computers, and they evolved, we moved toward industry 4.0, where how we have to optimum use our data that is we are storing, and how that data can speak to us as well as to different instruments for that matter, and how we can use this data that is generated day in, day out to get the benefits of AI based revolution that is coming in all the areas. So chemical engineering as a stream has also picked up, and all of you know that most of our energy demands are catered by the chemical engineering in one way or another way. So there is a new context in the industry. So this context is not just in any particular computer science or anywhere. It is also in the case of like chemical industries, chemical process industries. Once I say chemical process industries, it's still the petroleum sector is the biggest industry throughout the world. And that is the one of the biggest energy provider, and especially in the case of India. So what happens that the big data is something which deals with volume, that is to large size of volume of data, then its velocity, that is the speed of change. And it also deals with the frequency of change, because there are a lot of sensors and devices which are recording the data at a very high frequency. And then the variety of form of data. So in case of variety, so if I just say that we are not just recording temperature, we are also recording temperature, pressure, what is the catalyst deactivation rate. We are also, in case of industrial setup, we are also recording what is the flow rate, what is the density, what is the viscosity. Many things are being stored. And then veracity, because the uncertainty of the data. So because the system is uncertain, sometimes there will be some problem in your system. In suppose a multi-phase reactor, for an example, suppose if it is behaving in the same way, that is the normal operation way, it is good, but sometimes it behave in a way that is not desired. Then we need to, based on the data, we can identify, yes, there is some problem in our reactor. That's why we are not getting the favorable output. And then it is also the value, that is the business value it is adding. So what happens that this AI, it automates the monotonous task, and AI recognizes a subtle pattern in the industrial data and help in predicting when will problem occur. So that is one thing, that predictive analysis is done, where people try to predict if there is going to some misbehave of the system that is under consideration, or when it is going to require, suppose there is predictive analytics that is used for such type of operations. Then AI system gradually understand that each element better, allowing it to understand the pattern. So if we have a lot of data, we cannot just identify this data by any other way, because the data is large. As I said, the volume is very large, and the velocity of the data, speed of the change is very high, and that you have a very variety of data. So in this case, this AI help us to understand that each element better, and based on that we can draw a pattern, that what pattern it is reflecting. So big data, that is there is a lot of buzz around about this big data, and this is basically the widespread use of personal computers has started, and wireless communication led to big data. So because finally first we were using this computer for our personal use, then these computers were clubbed to industrial setup as well as this lab setups where we are recording this data. So we are producers as well as the consumer of data. If we understand this, try to understand these things in a simpler way. We are not just producing the data; we are also consuming the data. Suppose right now there are many people who have joined faculty, there is student who have joined this FDP. So you are the consumer, and there are a lot of data that is being produced. That yes, how many of you attended, what were your background, why you attended, and also there based on this data also we can draw some pattern. So this data is not random; it has a structure. So for an example, when someone goes to a supermarket, so it is like from the data whichever is recorded inside this superstore. So we can identify the customer behavior, that what type of things that customer is going to buy. So we need big theory to extract that structure from the data. So this data, as I told you, in a simplistic way, just the customer is just going to buy something, or it can be like suppose we are talking about hydrotreating or hydroprocessing in case of a petroleum refinery. So where there are a lot of data, but how to understand the process and how to make predictions for the future. Because whenever we are talking about industrial setup or any design of any instrument, and so if we can predict the future based on the data that we have recorded, it is a very great help. Even not just future, if we can just predict that yes, the catalyst life, suppose that is one example I am going to talk about, this catalyst deactivation. This catalyst deactivation is a very important phenomenon because, as all of you know, this catalyst is a very costly thing. So that's where all these companies, they want to use the best of this catalyst. So that's where to predict that yes, once what is the life of this catalyst, that is when this catalyst is going to deactivate, that is a very challenging thing, and that work has been started where people are doing this using this big data. So moving ahead, now I'm just setting up the context. So now why brain versus computer? Because our brain is something which all and along we want to use our computer in such a way that it also performs the same activities that our brain is doing. That is where our hope is with AI. In AI, we compare the brain or mind and the computer. Our hope is that brain is a form of computer. So that with that hope we are going forward, and we want to make that our brain, our computers are like brain, and we want to model our computers in such a way how our brain performs. And our goal is that we can create computer intelligence through programming, just as people become intelligent by learning. So just for an example, a kid, when that kid is in a young age, so that kid starts to learn the things, whichever language or playing activities and all, and that as he or she grow up, so that's how he picks up the things and they learn. So our goal is that we create the same type of computer intelligence through programming, just as people become intelligent by learning. But the point is that, but we see the computers that it is not exactly like brain. So computer perform tasks without understanding what is doing. And does brain understand what is doing when it solves the problem? So that is what we trying to map, that yes, how this brain is solving the problem and how it is understanding. This is something which we want the computers to perform. So in a nutshell, AI is basically artificial intelligence is the study of how to make computers do things at the moment people are better. So right now we are better than computers, and our objective or our pursuit is that we want to make these computers do things the way we are doing the things. So now coming to learning. So always we started with this learning, that we want computers to learn the way humans learn. So we identify if a system is going to act truly appropriately, then it must be able to change its action in the light of experience. So as we know that we do a lot of things in our life and we gather experience, and based on our experiences, we know that yes, we change our course of action. So suppose we get a bad experience in something, we are not going to do that thing. We always try to change our actions in the light of our experience. So that is that experience is that, or this learning can be clubbed as how do we generate new facts from old, then how do we generate new concepts, then how do we learn to distinguish from different situations in different environment. And further, so this was all about learning. So why we need to systems our computers to learn. But the basic question is why learn? So machine learning is basically, we always say machine learning. So learning is something which is related to that. Machine learning is a program is about programming computers to optimize the performance criteria using example data of past experience. So we, in a rough way, we can say that yes, the training data. We train our machine learning models with the help of a training data, and that is if we relate it to a human life. So that's where it is basically the past experience. So there is no need to suppose we are calculating a payroll. There is no need to learn because it is fixed for an employee salary. Learning is used when human expertise does not exist, like navigation on Mars. Humans are unable to explain their expertise, that is speech recognition. Solutions change in time, that is routine in a computer. Then solution need to be adapted for a particular case, that is user biometric. So these are some generic examples. And so first I will focus on some generic examples to set the context, then we will move towards chemical engineering applications. So what is a machine learning? So machine learning is basically optimize the performance criteria using example data or past experience. So that is example data is there or the past experience is there. And then we use the statistics, because a role of statistics is very important in machine learning, because that's where we can draw inference from a sample. And then comes the computer science, because we need efficient algorithm to solve the optimization problem, representing and evaluating the model for inference. So that's where we need to have a data. Then we need to have some statistic based idea, and then we need computer science algorithm, that is efficient algorithm to solve this problem. And moving ahead, we can say that a computer program is set to learn from experience E with some class of task T and a performance measure P. So that we have to have a performance measure, because how we will say that yes, our this computer program E has done some task T. So we have to make a performance measure, that is P, that comes from the statistics, and its performance at task T is measured by P, and it improves with E. So once we are getting more and more experience, this our computer program is going to improve. So now coming to this traditional versus machine learning based approach. So the traditional approach of computation was that you have a data, you have a program, you do computation, and then you get result. This is what we used to do. In case of machine learning approach, what we do that we have data, we have the output, we based on our computation, machine learning computation, we develop a program. Now this program can be used for different data and we can get the result. But in this case, we were using data and we developed a program, and from that we were getting the result. So this is how this traditional and machine learning approach is different, because here we are using this data and result. So we know both input and output, and based on that we are making a machine learning model for a small subset, and then we scale it up to a big so scale it up to get a program, and that program can be used for different types of other types of data that we can get. So this machine learning, we talked about that in case of industry 4.2 and big data era, there are huge amount of industrial data that are being routinely collected and stored. So, and this data is not random, and it can be used to predict outcomes. And this ML is a programming computers using data that is past experience to optimize the performance criteria that we have established. And then moving ahead, what we see that ML relies on statistics, numerical algorithms like linear algebra and optimization, and that a program that solves this ML problem efficiently. So this is something, this is the industrial data, and you can see this industrial data. If you just see in a first go, you will find out this is the industry from a chemical industry, or from a petroleum industry. You will see that this data looks like, yes, there is just a noise. You cannot find out any pattern from this data if you have to just identify using the conventional techniques or by your eyes. So that's where you need to do some artificial intelligence based pattern you can identify based on this data, because all this data is speaking something which we cannot just identify using our naked eyes. So why we are moving towards machine learning more and more, all the areas are going towards this, because computing power has improved. In case of 1985, this Cray 2 supercomputers, you can see this supercomputer, it was covering the whole of the building. And then it was having 1.9 gigaflops, 244 million hertz. And it was, the cost of this was computational supercomputer was 32 million. And now compared this to Apple Watch, and the specs I am talking about is in case of 2015. Now you can see how small is this. And here it is having the performance power of 3 gigaflops, 1 gigahertz, and the cost is just $300. So that's where you can see the performance per unit cost gain is around 1,50,000. So that's where once this computational power has improved and their size has reduced. So that's where we can identify the things that we can identify many things. We can do many calculations in a small amount of time, and that's where a lot of machine learning algorithms or artificial intelligence algorithms have come, and they started from the computer science, and then now different domains of engineering they are applying. And as a chemical engineers, we are also applying a lot of their things. So one important thing that is about this supervised learning. So in case of machine learning, the first important thing is that a lot of algorithms are based on supervised learning. So here the correct class of the training data is known. So what happens, this is your input raw data, but you know the class of the data. And then you run it through algorithm, and you do processing, and the final is that different, you are able to identify which class is which based on your supervised learning type of approach. So supervised learning, its user is prediction of future cases, use the rule to predict the output of future input. So now you have to suppose in case of petroleum refining, you have to predict what will be the output, or what will be the required output of any equipment for that matter, or you can identify what will be the future demand of gasoline or diesel for that matter. So all these things are future cases. Then knowledge extraction, the rule is easy to understand. It is also used in compression. The rule is simple. Then the data it explains. Outlier detections, exceptions are not covered by the rule. Fraud, so fraud detection or outlier detections can be used. Okay. So in case another class of machine learning is unsupervised learning, and in this case the correct class of the training data are not known. So here the input data is there, but you don't know the correct class. So that's where you use unsupervised learning. Then you do interpretation and followed by algorithm and processing, and from that you can get the your output. So the basic difference here is that in case of supervised learning, you are knowing the correct class of your training data, but in case of unsupervised learning, you don't know the correct class. So here learning what normally happens, no output clustering. It is for clustering, that is grouping similar instances. Examples are customer segmentation, image compression, bioinformatics. Then another thing is reinforcement learning, that is basically using a lot of apps and all and gaming softwares. So in this case, it allows the machine or software agent to learn its behavior based on feedback from the environment. This behavior can be learned once and for all and keep on adapting as the time goes. So this is your input data, and this is your agent, and this is the environment. And based on that, best class action is taken, and there is some reward, and there is some based on the reward, next action is taken, and based on that you get the output. So in case of reinforcement learning is a policy that is a sequence of output, no supervised output, but delayed reward. So based on this reward, this reinforcement learning goes on, and credit assignment problem can be one, game playing, robot in a maze, multiple agent, partial observability. All these things are the examples at the domains where the reinforcement learning is used. So simple is the Mario game that I think most of us might have played. I don't know about. So in this case, the data learning is that the actions are performed and then feedback is given. So if punishment is there or reward is there, so the user wants to go ahead, and that's where this reinforcement learning, based on this reward and punishment, it learns and it goes ahead. So how this machine learning works? Basically, its first phase is the learning, then pre-processing. The data is cleaned, supervised, and supervised based on you select. Then you make up performance test that what measure performance you are going to take. whether it can be the mean square error or it is going to be root mean square error, what type of criteria you're going to set. Then you test different types of algorithm, whether it will be support vector regression, ANN or CNN, whatsoever you are going to do. Then you do the prediction. Once your model is ready, you do predictions on new data and you find out how your predicted data is going to look. So now coming to in case of chemical engineering, so what we see that there are still these oil and gas companies, they are the biggest energy providers throughout the world, and they are also the biggest company in case of their net worth. So now this is Shell. What Shell is saying that they have developed AI powered service that answer customers common lubricant questions in seconds. So this is where AI is taking the leverage, Shell is taking the leverage of AI. And what ExxonMobil is doing that I'm just taking an example to show you that yes, all these petroleum companies, which is the biggest chemical engineering companies, we can say chemical process engineering companies, they are. So what they are doing. So ExxonMobil is taking help of AI robots for oil explorations to improve natural seep detection capabilities. Then Mitsui Chemical, another giant chemical company, what they are doing, they are using AI to accurately and speedily predict quality of gas product. So they are into natural gas business, and they are trying to find out what is the quality of their gas product based on the AI. What BP, that is British Petroleum, is doing, they are saying that by 2020, 85% of the customer interaction will be managed without a human. So they are going to use an AI interface for that. So now coming to a example of ML in petroleum refinery. So we can see that yes, petroleum refinery is there, but how this machine learning is going to be applicable in case of petroleum refinery? There are various things which ML can do in case of petroleum refinery, and there are a lot many applications which have now found a way in case of petroleum refining, and a lot many industries are using this. The first is the predictive maintenance. Suppose this is a compressor we are talking about, or we are talking about heat exchangers, or we can talk about any unit operations we can see. So in that case, predictive maintenance is first thing where ML can be used in case of a petroleum refinery. Another thing is the linear programming. In case of linear programming, we can do this. We can take the help of machine learning to find out. So this is your crude distillation. How we are going to make this blending, because the final product, or whether it be gasoline or diesel, and also it depends upon there are different processes that is going on in a complex petroleum refinery. How to make there are different baskets of product, and how to blend this basket to get your finalized product. That's where linear programming is used in case of petroleum refinery, and their machine learning is used to ease this overall computational thing. So now coming to the next application is process modeling. In case of process modeling, like your today's catalytic cracking, hydrocracking, distillation, or diesel hydrodesulfurization. So here also we can use the process modeling. We can leverage machine learning for predicting their products, their yields, their different type of things that we can convergence. All these things can be predicted using combining machine learning with process modeling. Then another example is remaining life prediction. Remaining life prediction, for an example, the catalyst life. What is the catalyst life that is remaining? Because catalyst is a very costly thing, and all these companies, petroleum refining industries, they want to use the maximum of this. So that's where, and also they want to reduce their shutdown time. So that's where this prediction of this catalyst life, remaining catalyst life, is very important. It is not just important for a single unit, because once this single unit, suppose this FCC is not just a unit in a standalone, it is connected with other units. If they have to take a shutdown of FCC, and that's where if they don't know the exact time of suppose a hydrocracking when it is going to be shut down. So this hydrocracking FCC are in sync with each other. So that's where suppose this catalyst of this hydrocracking has to be changed. So that's where the catalyst life that is remaining of this hydrocracking is very important to know, because once this hydrocracker is shut down, all the units have to take a shutdown, or their production has to reduce. So that's where the correct prediction of this remaining life is very important. Then risk assessment, because these petroleum products they are highly volatile. So that's where there are a lot of safety and hazard risks that are related to these industries. So that's where risk assessment is also with the help of machine learning is being done. Then prediction of product demand. So that's where how this need will increase. Suppose this gasoline demand, how it will increase, or this diesel, because right now the diesel demand has saturated. Most of the companies are moving toward petrochemicals. So all this need can be predicted based on this machine learning. Then the prediction of supply shortage. Then recommendation for blending, that is food products and all. So in case of process modeling, you can see this FCC, hydrocracking, distillation, and DS. All these have one reactor or another multi-phase reactor. So here you have fluidized bed reactor. Here you have fixed bed reactors. Here also you have fixed bed reactors. Hydrocracking, you also can have a slurry hydrocracker that is coming. So here in this case, you can see that this is related to the topic of my presentation, that yes, in case of process modeling, how these things can be related to each other. And I'm just giving you examples where this machine learning has found a way. In case of petroleum refinery, that is the biggest energy producer still in our country. So in a nutshell, artificial intelligence in oil and gas industry, that today AI is helping the oil and gas industry to chart its future course. The important and popular applications of AI are like intelligent robots that we talked about. So this robot designed with AI capabilities for hydrocarbon exploration and production to improve the productivity and cost effectiveness. So Exxon and Total are using that. So Total is a company from France. And then virtual assessment, like online chat platform that helps customers to navigate through their product database and process general inquiries using natural language processing. So next is that remote operations. So now during this remote operation and their performance shutdown using IoT, that is Internet of Things. So these industries, what they are doing, that they are taking the help of machine learning, deep learning, and Internet of Things that could potentially revolutionize the oil and gas industry. So they based on that, remote operation with the help of IoT can be done. Okay, and there is in case of a suppose oil drilling platforms, and there is no need for people to check all these platforms each and every time. So there can be you do this remote operations using this IoT, remote notification alarms and performance shutdowns. All these things can be done. So now another example of machine learning for a smart solution for FCC that is being developing. So FCC being a multi-phase reactor, how this machine learning is being used in this case is that this machine learning based algorithm is proactively predicts this FCC yield, because in case of FCC the kinetics is very complex and there are in n number of products that are formed. So therefore this yield of FCC prediction is a very important thing for any refiner. So that's where this machine learning based model, it predicts the FCC yield in response to any potential change in the refinery feedstock, because this refinery feedstock, that is the crude oil, that it is not just coming from one source. The source is changing, because sometimes it comes from, suppose Basra crude oil, it is coming from Iraq, sometimes it comes from Nigeria, sometimes it comes from Saudi, or now we are also taking the crude oil from US. So that's where their product, their quality, the crude oil qualities are different. The sulfur contents are different, aromatic contents are different. So that's where this FCC yields will be different. So now just by changing this refinery feedstock and using this machine learning, can we predict what is the FCC yield? Now not many companies are doing that. Then prediction of kinetic parameters. So this prediction of kinetic parameters is very important, because as I told you, this is a very complex reaction that takes place in case of FCC, and the overall conversion efficiency weighting the actual operating conditions, because these actual operating conditions are going to impact the overall conversion. That's where operating conditions with this estimated kinetic parameter is very important for predicting the overall conversion. And it also helps to avoid the unplanned downtime. So there are a few things I will talk just about this machine learning part of things, where a lot of things have been used for multi-phase reactors. So now we know the context, that yes, why machine learning has come up, why in case of industry 4.0 we talked about this. Then we talked about petroleum refinery. I took petroleum refinery as an example, where many chemical engineering applications are there, and where there can be several use of machine learning. So first I will, so there are many things which is done, which can be done using machine learning for multi-phase reactor. First is the experimental investigations. People are doing a lot of experiments where flow regime analysis, hydrodynamic parameter estimation, all these things are done using techniques like novel techniques like PIV, and then radioactive particle tracking, and all these things. So in these experimental techniques, machine learning is being combined with this technique to better estimate these hydrodynamic parameters. Then CFD, computational fluid dynamics. This computational fluid dynamics is used for scaling up the process or understanding the process, because we cannot do the experimental investigation for each and every case because it is a very costly thing to do. Experiments are very costly. So that's where computational fluid dynamics is done, or the CFD analysis is done. And that's where if this CFD is combined with machine learning, because the CFD is still, our computers are not that fast that we can do like DNS type of simulation, direct numerical type of simulation or so. That's where we use Euler-Euler simulation. And even this doing Euler-Euler simulation for multi-phase reactors for a large scale industrial setup is not possible. It's not feasible. Still with our given our computational resources that we have. So that's where this CFD coupled with machine learning, it helps a lot in doing CFD. And then the last point is this plant data analysis. In case of plant data analysis, machine learning is used for identifying different types of things in multi-phase reactors. So case one, I will just take for application of for this boiling flow, and this application is related to another important multi-phase reactor, that is boiling water reactor. So this boiling water reactor is having is a multi-phase reactor where two phases are present, that is steam, vapor as well as water. And in this case, what happens that identifying the flow regimes, identifying the local velocity, the void fraction is very important for their design and safe application. So this is work that that we did, and in this case, just to give a brief about this forced convective boiling flow. What happens in case of forced convective boiling? This is a tube which is heated from outside, and you can see that bubbles are being generated. These bubbles, they coalesce together and they form big bubbles, and so it starts with forced convection, and then it goes to subnucleate boiling, and finally it goes to saturate nucleate boiling. And in case of boiling water reactor, as we this example is directly relevant to boiling water reactor. In this case, this critical heat flux and flow instabilities are very critical parameter for the design and scale up of this boiling water reactor as well as the safe operations. So that's where this critical to this boiling water, these two phenomena, they can be, if you need to identify when this critical heat flux will we are going to achieve this critical heat flux, or when this flow instabilities will take place. So though in that cases, these are the key issues that need to be quantified. That is the hydrodynamics, heat and mass transfer, the simultaneous heat and mass transfer takes place. And further, this convective and nucleate heat transfer, both things occur simultaneously, and this bubble nucleation and condensation. So in this case, these small bubbles, they are nucleating from this surface, and then they are have a tendency to coalesce together, or they have a tendency to condense. So because this overall the water is at a lower temperature compared to the surface temperature of the tube. So that's when all these key hydrodynamic key parameters are very important to identify. So once you have a clear-cut idea of these key hydrodynamic parameters, heat and mass transfer and all this, then you can have an effective control on your critical heat flux and flow instabilities. So that's where in this case of boiling flows, heat and mass transfer, multi-phase flow, fluid dynamics, all these things are combined together. So if you see in a bigger picture that this is a tube that is being heated from outside, and if a liquid flows from the bottom, so we can observe different types of flow regimes in this case. So it starts with liquid single phase flow, that is liquid is subcooled and heat transfer to the liquid is by forced convection. So this is a single phase flow. And then nucleation starts and small bubbles, they come from the surface. And then we, in this case, we can identify the individual bubbles by even with our naked eye, and that is the bubbly flow. And further, these bubbles, they coalesce into slugs of vapor, and they have moderate mass qualities. In this case, we identify this flow design as slug flow, and further we get to have a annular flow. In case of annular flow, the core of the flow consists of vapor only, liquid adjacent to walls. Then mist flow is here. In case of mist flow, a sharp decrease in the heat transfer coefficient takes place. And finally, there's a vapor phase, single phase flow. That is, the liquid phase is completely evaporated, and this is your single phase. So this boiling flow, it progresses from this single phase, that is liquid, and finally it can end with the vapor phase. But our objective in case of boiling water reactor is that we do not cross this annular flow regime, because once, as I show you, that in case of mist flow, there is sharp decrease in the heat transfer coefficient. When this sharp decrease in the heat transfer coefficient are there, then critical heat flux can take place, and also the melting of this tubes can take place, or the melting of the nuclear rods in case of boiling water reactor can take place. And once this type of melting takes place, then there are different disasters that can take place. And one example was the Fukushima nuclear disaster that took place in Japan. So that's where that's where the objective here is that how well we can have a control on our critical heat flux as well as this flow instabilities. So that's where you need to have a clear-cut idea of this flow regime, the liquid local liquid velocity, what is the voidage at each and every axial location. That's where this type of data is very important. Now coming to this, once I talked about this measurement of this local liquid velocity. So this local liquid velocity in case of boiling flow is very important. So there is an important technique which is used for this, and that technique is known as radioactive particle tracking. In this technique, what we do, suppose this is our test case that where we performed our experiment. In the test case, what happens that this is our tracer particle, that is the gamma ray emitting tracer particle, and these are the sodium iodide with thallium dot detectors. And now once this flow is continuous inside this system, so this liquid, once suppose we are trying to trace the liquid, we will make the tracer particle nuclear buoyant. So suppose we are talking about water, so we will take its density, the density of our tracer particle equivalent to that of water. And in another case, or another thing is that we always try to make this tracer particle as small as possible. So in this case, in this technique, a tracer particle is made by encapsulating a high energy gamma ray source in such a way that it behave like other fluid particles of the phase whose velocity is to be mapped. The particle is made neutrally buoyant for tracking liquid phase, and the motion of this tracer particle is tracked over a long time over array of scintillation detectors. So these are the scintillation detectors. So what happens that in this case, in case of radioactive particle tracking, we do counts from we get counts from detectors. So all these detectors, they are recording the counts, that is the gamma ray counts. And then we have a position count map, that is the calibration data. This calibration data is performed before experiment, in which this tracer particle is placed at several known locations inside this test section. And so now we have the location, that is the XYZ, and we also know what is the photon counts with respect to all these detectors during this, when we are making this calibration data. And then we use a reconstruction algorithm to find out the instantaneous position with respect to time, and then we can do the time difference between successive location, and from that we can easily calculate the instantaneous velocities, and from that we can calculate mean velocity and fluctuating velocity, and from that we can do a lot of time series analysis, and then we can also get turbulence time quantities. But the point is this reconstruction algorithm. So the conventional way of doing this reconstruction was, so this is the text section with RPT arrangement. So this is, we did experiment for not for single rod, but for the multiple rod as well. So this is how this was the liquid inlet, and these were the heater rods, and these heater rods were electrically heated, and this was the liquid outlet, and these were the detectors that was placed inside this outside this system. So this is how this tracer particle position reconstruction looks like. In this is the test section, this is the detector, and this. So I'm not going into details of this, but I will get to the point where machine learning is used. So in this case, this is the photon count rate. C is related to this formulation, where activity of the particle is their absolute efficiency, and phi is the photo peak fraction. If all of you must knowing that all these nuclear sources, they have a photo peak. So since we are using this scandium, it has one peak. Suppose we are going to use cesium. Cesium will have two peaks. So we always want to have a photo peak. That is the counts that are coming from the photoelectric effect, not from Compton backscattering or so. So in this case, this absolute efficiency of the detector is a very complex function of their position and the area subtended and a lot many things. So I'm not going to detail of this. So, and what happens that once you are making a position reconstruction algorithms, so you have to identify these three parameters, where detector parameter, that is the this A, mu, and tau. All these parameters have to be detected dead time, what is the attenuation coefficient, what is the source strength. So these are the three parameters that has to be identified. And then this optimization function has to be minimized. And then once you have all these parameters, then you identify you do this positional reconstruction by minimizing this function. So this is the pictorial representation of the original setup. That is, yes, these are the detectors. These are the multi-phase vessel. That is the boiling flow vessel in which the bubbles are there and all things. These are the top view of the detectors that are being placed. And what happens that behind this, there is a concept known as shadow effect. What happens that this is the shadow region, this is our detector. So most of this RPT has been done for this multi-phase reactors in which there were no internals present inside the system. Like for an example, bubble column or fluidized bed reactor. So, but this was the first time we were using this radioactive particle tracking for this boiling flows. And in this case, what happens that you have a shadow effect because of this heater rods. So that's where this, not only the attenuation of this medium that is present inside the column that is hampering the rays that is coming to the detector, but another thing is that these heater rods were solid. So that's where the conventional techniques like Monte Carlo algorithm that were used for predicting tracer particle positions or this reconstruction algorithm were not useful in this case. So that's where we first come up with the first algorithm using this AI, that is the Monte Carlo real coded genetic algorithm. This was the flow chart. So that's where we were identifying this parameters, detector parameter, that is A mu tau, source strength, detected dead time, and as well as the attenuation coefficient using. So this was the flow chart of this MC based real coded genetic algorithm technique. And further, once we have this A mu tau, then we were using this optimized value. And again, we were using this genetic algorithm to find out how the tracer particle positions. So this is the application where not in this case, there was a technique. There was a technique for measuring the liquid velocity or solid velocity or any for multi-phase reactor. But the point was that that was not applicable to unconventional type of thing, that is the boiling flow, when we first tried to use this for boiling flow. And in this case, what happened that we have to come up with some other techniques so that we can get the good data. And in that case, AI helped us. This is the first example of this case. And then what happened that we moved, still the overall time that was taken by the reconstruction was very long. So it was in days that we had the reconstruction phenomena took place very long time. Then we come up with this SVR based position reconstruction, in which this target output, that is the particle position, and the input vector was our photon counts from N detectors. And that's how the support vector formulation was made for our case. And then we compared our support vector regression formulation with RBR, that is relevance vector regression position reconstruction. Because another idea in case of RPD was that can we do this online reconstruction? And for doing this online reconstruction, our reconstruction algorithm has to be very fast. So that's where we compared different types of algorithms. And this was our ML based position reconstruction algorithm. So this was our input vector. This was our training. We did kernel calculations, and from that we get our tracer particle positions. And similar was for this RVR, only there was a few difference in these weights and all. So in case of detailed information constituting a direct physical relation between the input, that is a photon counts corresponding to array of scintillation detectors, and corresponding outputs are not required in this. So in case of conventional Monte Carlo algorithm, what thing was then that this there was a relationship between direct relation, that is the first principle based model was used, and that's why it was taking a lot of time for getting this generation of position reconstruction. But in case of machine learning based models, there was no detailed information of this physical relationship was not required. And further, SVR model, in the case of SVR model, the chances of getting trapped in the local minima is avoided, as the objective function is in complex quadratic form and it possesses a single minima. And in case of RVR model, it is compact, computationally efficient, which leads to generation of simple and smooth regression functions. So that helps us in online monitoring. So this support vector implementation. So the support vector implementation was done. First step was this data collection. So in case of data collection, we collected this training data set, that is calibration data, and then we have a target output, that is the position of this tracer particle. And so this was the first thing. We collected the training data, that is the calibration data was used for the training. And then we did the scaling of this training data from 0 to 1, because in some cases the even source is very far from the detector, the count will be very less. Once the source is very close to the detector, the counts will be very high. That's where we need to do this scaling. So that, and then we did estimation of SVR parameter, that is C, epsilon, and gamma using K-fold cross-validation. Then we established this SVR model, that is the establishment of the final SVR model for reconstruction of the tracer particle position employing optimally estimated SVR parameters. And then finally we got this SVR prediction of experimental data. And for relevance vector regression position reconstruction implementation, we did data collection, training data, that was same calibration data was used, and then it was scaled from 0 to 1. And then RVR model training was used. And in this, we identified the kernel parameters using hit and trial method. And then estimation of RVR model was done. And finally, RVR prediction of experimental data was done. So this is how, so as I told you that statistics is very important in case of, because you have to set up a condition that how you're going to evaluate your model, that whether it is good or not. In our case, that was the mean Euclidean distance error. And this is where you need to have an idea of your problem that you are going to deal with, because as this machine learning is, you cannot just use machine learning as a black box. Until unless you have an idea of the physical problem or the physics behind the problem that you are solving, you cannot use this machine learning, because it will give you a result, but finally it won't be of any use. Because if I can give you a training data, a test data, and then you based on, you will just plug it into any software, and you can get that, yeah, these are my output. But whether whether these outputs are realistic or not, that's where you need to have a clear-cut idea of the problem that you are dealing with. So in case of our case, the mean Euclidean distance error was our statistical parameter, because in our case, once we are predicting the tracer particle position, how close it is to the real position. So that is the mean Euclidean distance error. That is the distance between two positions in the 3 dimensions. So in case of support vector regression, we got the minimum error, RVM followed by RVM. ANN was giving the maximum error, and MCRJ was close to SVR, but the point so this is what we got. And then another thing is that this was the thing for this conventional application of multi-phase reactor, like bubble columns or so. But once we move to unconventional areas of application of RPT, that is the boiling flow, and so we observed that this MCRJ was performing the worst because of the shadow effect. So that's where the SVR performed the best, followed by RVM and ANN. And then because our another objective was to do this online prediction of the particle position. So that's where this number of support vectors or relevance vectors, so that relates the compactness of your model. So in this case, we saw that the number of calibration data that was used as a support vector or relevance vector. In case of RVM, it was the least, and that's where the model complexity was the least, as well as therefore the performance of this RVR in terms of time was best. So that's where we compared this with respect to tracer particle reconstruction for one position. In case of SVM, it was just 0.07 millisecond. In case of RVM, it was 0.005 millisecond. And for a million tracer particles, because once we are doing the experiment for 8 hours or so, we definitely have more than million tracer particle positions. So SVM was doing the same business for in 70 seconds, RVM was doing it in 5 seconds, and MCRJ was taking around a day. So that's how we leverage this machine learning based efficient calculation in our radioactive particle tracking, and that we use for identifying the liquid velocity in a multi-phase reactor, and the multi-phase reactor considered here was a boiling flow reactor. So this is how this RPT volume discretization. So for 3 rods, we did such discretizations to get the velocity and all. And further, these were the vector plots that we identified using machine learning based position reconstruction for radioactive particle tracking. This shows that how that this liquid flow is taking place. It is rising in that near to the heater rod and going down in the column wall region. And these are the velocity vector arrangement for inlet flow rate of 5 LPH at T in of 50 and T in of 70. In this case, you can see the vectors are of a small size because the liquid velocity is very less. But once this inlet liquid temperature is 50, once the inlet liquid temperature is increased, then the bubbles of bigger size are formed. And once this bubble, because the rise velocity of bubbles is higher as compared to liquid because their density is low, then they take liquid with themselves, and that's where the liquid velocity is increased. Finally, we identified the liquid velocity profiles for different conditions at different axial heights, and these are very important not for the computational fluid dynamics but also for the getting the realistic picture what is happening inside the system. So these all were the time average liquid velocity profiles that we got. And now coming to the second application. The second application is application of ML for DSDS. Just I will take a break for water. So this is the case study 2. So first study where we leverage this machine learning based model for our radioactive particle tracking that was used for measuring the liquid velocity inside a multi-phase reactor. Now another thing is that for a petroleum refinery unit, that is DSDS, that is diesel hydrodesulfurization. So this diesel hydrodesulfurizer units, they are used to reduce the sulfur content of the diesel, because based on this, all of you we must be knowing that now we are in the all these cars and is BS6. That's where the sulfur of the diesel that you are using had to be less than 10 ppm. So that's where these DSDS units are used. So so what happens that in case of DSDS, we are using these trickle bed reactors. These trickle bed reactors are multi-phase reactors in which feed and hydrogen goes through the packed bed of catalyst or the fixed bed of catalyst, and then there are quench streams. The hydrogen quench streams are there, and this output is again sent to a separator from which hydrogen recovery and fractionation of the gases take place, like gases, gasoline, diesel, and all. So in this case, liquid flows in downward direction, that is trickle flow, operates under high pressure and temperature. Hydrogen to oil ratio is set to a high level, so that less than higher than stoichiometric amount, so that this catalyst deactivation can be reduced. And then further unconverted hydrogen is recycled back. So in this case, in this study, our objective was the prediction of weighted average bed temperature. So if we can go further, so you can see that in case of industrial trickle bed reactor that is used for hydro processing, that is for an example, we are going to talk about diesel hydrodesulfurization. There are multiple beds. This is the bed 1, this is the bed 2, and this is the bed 3. In this, there will be some weight of catalyst, there will be another weight, and there will be this is the bed 1, bed 2, and bed 3. So W1, W2, and W3 will be the weight of catalyst in first bed, second bed, and third bed. So that's where prediction of weighted bed average temperature is very important for from the perspective of petroleum refining, because this weighted bed average tells you that if you're whether how in less temperature you are going to get the desired product or not. If you are not so once this catalyst it starts to deactivate, then you have to increase the weighted bed average temperature, because all of you know that if the temperature is increased, the kinetics of the reaction is increased, and then you can get the better conversion. But it also tells you that if you are subsequently you are increasing the WABT, it's a indicator that yes, your catalyst is deactivating. Then another objective was prediction of product quality such as sulfur aromatics, all this, and then development of a graphical user interface and linking it with Process Explorer. So Process Explorer is basically Aspen's Process Explorer is there, which is used in all the petroleum refining industries to link all these sensors that are placed inside this reactor, inside the different units. So here there were a lot of sensors that were used to track this feed flow rate, hydrogen flow rate, then what is the temperature inside this each and every bed. So there were not only one sensor, but there were different sensors that were played radially and axially across this. Then the pressure, what is the pressure inside this, and then what is the hydrogen temperature sensors were placed, and what is the hydrogen flow rates in this quench. Then at the bottom, then what is the product quality of all this? So there are different type of sensors. So all these things, our objective was that to link all these things with a graphical user interface, so that operator who is operating that unit, they have to just punch in few numbers, and based on that they can get the overall prediction of what is the product quality, that is sulfur and aromatics, WABT, that is the weighted bed average temperature. So these quantities are very important for refinery operation, because once you have knowledge of all these parameters, then it is very easy for you to operate your plant. So how we did, so first thing was that we did data collection. This data collection was using this tag identification. So tag is basically that number of each and every sensor. That is, suppose it's the pressure sensor, suppose it's the temperature sensor, it's the flow sensor or level sensor. So all these sensors were placed, and then we also collected the lab data. This lab data was used for the prediction, for the checking, validating our model. Then we did data cleaning, that we removed the redundant data and the data filtering. And that's where, in this case, so data cleaning can be done in various ways. But the point is that if you have a clear-cut understanding of this DSDS, then only you can identify that whether it is a redundant data or you need to have some data filtering or not. So that's where once someone who is from chemical engineering and we are this to this whole gathering, I can just suggest that whatever problem you are solving, don't just solve this problem based on input and output data. First and foremost, you need to have a clear-cut idea of what you are going to do that, and then only you can identify that yes, what type of things are there. So as someone was, I just saw that some question popped up that how you are going to do this data cleaning. So because in case of data cleaning in this here, suppose you are getting a sulfur, because you know the feed sulfur. What is the feed sulfur? Suppose the feed sulfur is 10,000 ppm, and then in the data, what you are identifying that you are getting a feed sulfur of 15,000. So that is something, a noise. So you have to remove it. So this is how we made different types of metric for removing the redundant data or the data cleaning. So we also know the temperature of our bed, that yes, the input temperature is this. If we are getting something which is very redundant numbers, we removed that. And then sulfur content was there, aromatic contents were there. So based on that, based on the problems physics, we identify the data cleaning numbers metric, that how we are going to remove that data. Then the next thing was model implementation. In this, we did SVR based model development. We splitted the overall data into training and testing data. We selected different type of ML model, that is logistic regression, decision trees, support vector regression, and then we did tuning of model parameters using k-fold cross validation. Then a model validation was done using the lab data. And then someone is asking which tool. So I think there are a lot many tools in Python and everywhere that you can do. But my point is that tool is secondary. Once you have idea, you have a physical idea, then you can easily remove that. Even this data cleaning you can do in Excel. Okay, so and then model validation was done using the lab data that we collected. That is the prediction of remaining data, statistical analysis, all these things we performed. And then we developed a front-end development was done. That is the graphical user interface and presentation of the data. So this is how our support vector regression flowchart looks like. First, we did collection of data, then we did normalization, and further we from this we got this our training data set, then testing data set, and from this training data set and testing data set, using this training data set, we optimized our SVM parameters. And once we have this our optimized SVM parameter, we moved to train our SVM model. So we did the training of our SVM model, and then we got our optimal SVM model, and we did the predictions of our testing set, and ultimate model predictions were found. So this is how our SVR flow chart looks like. So in this case, the input and output is there. So in our case, the input vector was diesel flow rate, recycled gas flow rate. The recycled gas flow rate is nothing but the hydrogen flow rate. The feed density, what is the density of the feed, and what is the feed sulfur. Then based on this SVR solver, we obtained a support vector, kernel calculations were done. And then we got this bias. And from that, our objective was to find out this product quality parameters. That is, in our case, it was product sulfur and WABT. So we did product quality prediction using these input parameters. And we have a training data set. As I told you, the training data set was recorded we got from our real industrial scenario, from the different types of tags. And this data was not recorded for few hours or few seconds. It was recorded day in, day out, 24/7. As all of you knowing, these petroleum refineries, they operate 24/7. Once you have a 24/7 operation, then you can see the huge amount of data that we can have. And by leveraging this huge amount of data, we try to predict these many parameters. Then we did some types of sensitivity analysis. because in the case of petrol, in the case of this DSGS unit, because since I told you that each data was recorded for every second, and now in case of petroleum, in case of refinery, we are not just talking about data that is for 1 hour or 2 hours. The data we can use for 365 days. We can have data for 20 days, 30 days. So that's where the point was that we need to have some averaging. We need to do the averaging of the data, because we cannot take each and every second data, because otherwise it will make our model too complex and it will be very difficult to process such type of data. That's where we did lot of averaging, that is 2 hour averaging, 4 hour, 6 hour, 8 hour, different types of averaging we did. And the point was that we first chose a statistical parameter. Based on that, how we are going to get that, we took this RMSE, that is root mean square error, for doing this type of sensitivity analysis. And this was our DSGS model data error results. So first was that we compared it in terms of product sulfur. This is the product sulfur plant data, and this is the product sulfur model data. And here we can see that this 4 hours data, in case of 4 hour data, the root mean square error, we found out that yes, if we are going to average the data for 4 hours, and we are going to take it as for the model development, then yes, the model predictions were quite good. And in this case, you can see this is the scatter that we found out, and the root mean square error was 1.7. And in case of WAVT, that is weighted bed average temperature, the root mean square error was 2.96. And then moving to, so another thing was that the idea was that in that case, in the case of what we are dealing about, so we were talking about Euro 4 to Euro 6, that is the BS4 to DS6 to BS6, and that's where we found out that yes, there were some changes. So once you are processing Euro 4, then things were different, and once you are processing Euro 6, then the things were different. So that's where we try to bifurcate our model in these two things, whether we are going to predict the things for Euro 4 as well as for Euro 6 or not. So in this case, the input data we took from yearly data was there. So it was around year or so. The input was inlet liquid temperature, inlet liquid flow rate, total recycled gas, feed density, and sulfur. And we did data cleaning and filtering. The SVR model was used, and output was product sulfur and WABT. In case of Euro 6 model, the DSGS model results were like this, that there were different type of statistical parameter and confidence interval that we found out. And we did the exercise for 1 hour average data, 2 hour average data, then 3 hours averaging we did. And then we also did averaging for 4 hours, 5 hours, 6 hours, 7 hours until 8 hours. And there were different types of results. We got different type of sensitivity analysis we did. And then what we found that the model was trained for different hourly average, and corresponding predictions were made for 1, 2, 3, 4, 5, 6, 7 till 8 hourly average data. The reported values of we reported the values in terms of root mean square error and 95% confidence interval, and average of the predictions of 1, 2, 3, 4. This. So the final model that was developed in that case, the sulfur was prediction plus minus 1.38 in the band of 95% confidence interval, and WABT was prediction plus minus 2.15 in the band of 2.15 confidence interval. So, and then model predictions. So what happened that model predictions improved significantly after considering the data of Euro 6 only, including inlet liquid temperature and input temperature. So these, I'm just talking about that these were the few findings that we found. So one thing is that you can just train your model, you can get some result. But once you have an idea of the clear-cut idea of the what type of domain you are going to get, then in this case, what happens that once you dig deeper using this data analysis and all, then you will find out that you can do a lot of improvement in your things. So what we found out that once we considered only Euro 6, not Euro 4 and Euro 6 together, and we also included one more input parameter, that is the input liquid temperature to the model. And that's where we found out that yes, once we have such type of data, we are going to get better accuracy. So that's where we found out that yes, in case of WABT, considering both the data of Euro 4 and Euro 6, and then the WABT considering the data of only Euro 6, these were the differences. So you can see the root mean square error for WABT considering only Euro 6 and considering liquid inlet temperature as another input parameter has improved our data significantly, predictions significantly. So this was the predictions. This is the sulfur predicted by the model. This is the sulfur from the plant, and this is the WABT predicted, and this is the WABT plant. So another exercise that we did was that what is the minimum size of data? Because once we can have yearly data, we can have 2 year, 3 year, 4 year, but what is the minimum size of data we can have that will give us a better, so suppose whatever we set the parameter metric that yes, this is the best prediction we are getting, but in how many days we are going to get that. So that's where we did another type of sensitivity analysis, that is sulfur predictions using only 1 hour of average data. And then we trained it with 15 days data, 30 days, 60 days, 90 days, and 120 days. And that's where we first did one selection, that is the random selection of the total data. And this is the 95% confidence interval that we got. So once we are increasing the number of days, definitely the model predictions were increasing. And in another exercise, what we did, we select the first 15 days data from the total overall pool, and then we selected only first 30 days data, and then only 60% data, and then only 90 days data, and then 120 days data. So what happened that if you are selecting this random selection of the data you are doing, then you are getting the overall 120 days were good, and also the confidence interval was very less, that is 1.78 you are getting. So that's where, because once you are selecting the data with the random selection, you are having a idea of the overall gambit of the data. If you're only selecting the first data, then you don't have the overall idea of the total gambit of the input parameters as well as the output parameters. So that's where the model predictions are best for randomly selected data from a pool of total data, as it sees varying process conditions. And so that's where this type of observations we identified. So that's why I started with a slide, and in that slide that data is not random, and that's where you can identify a lot of things from this, a lot of structures from this, and a lot of predictions, lot of understanding can be developed based on this data. And that's where you'd have to clear-cut idea. Once you have a clear-cut idea of the physics of the problem, and that once you have an idea what type of models you have to select, what type of, whether you are getting the result that is realistic or not, and once you have idea of all these things, so that's where I am saying that you have to have idea of machine learning, but also you have to have idea of the problem that you are solving. So given, suppose we give this problem to a computer science person, and to give him, yes, you solve this, that fellow won't be able to solve this, because that fellow does not have an idea of your machine learning, your DSDS operations. That's where these are interdisciplinary type of research problems, or interdisciplinary problems, where you need computer science as well as you need chemical engineering. And that's where these two, if two gentlemen, they sit together having idea of both machine learning or engineering problem, and that's when you combine these two streams, then you have a better idea of the process, or you can understand the things better. Then we developed a graphical based user interface, because this graphical user interface is very important for if you have to do these things in a very smart way. So what happens that because a person who is operating the plant, that person cannot have we cannot expect that person to know each and everything about machine learning and all. So that's where what happens, that if a person is only wants to just put in few numbers, so what happens that this was our graphical user interface that we developed, and this was this recycle gas flow, and we were talking about 2 reactors here. And in this 2 reactor, we were having 6 beds, and we were averaging, taking this WABT based on the 6 catalyst beds. Our input parameters were liquid flow rate, gas flow rate, feed density, and feed sulfur. So liquid flow rate was in tons per day, and this gas flow rate was normal meter cube per hour, and feed density was in kg per meter cube, and feed sulfur was WPPM, that is weighted parts per million. And our output parameters for sulfur, WABT, density, cetane number, all these things we did. And then there was we developed a tab where just to simulate, reset, exit. So this is very important that you know a lot things about this, but once you're presenting your work to the audience, what type of audience you are referring to. If someone is not an engineer or a person who is operating a plant, need not know about machine learning, or he or she is not interested at all. The only thing that they want is that how well they can just click on this, they can get the data, and how well your model is predicting and all that, all things goes in the background. So this is how what happens. If you punch in these numbers, you just click simulate. These were the output parameters. So these were quite helpful for operators as well as the management for deciding that their day-to-day operation, as well as to take decisions based on this, or that what flow rates they need to change, what temperatures they need to set and all, because based on that they can identify that yes, if we are setting a flow rate of this, we are going to get sulfur of this, WAVT this, then whether we have to increase the gas flow rate, that is the hydrogen flow rate, or reduce the gas flow rate and all. So this is was quite helpful for the in terms of operation. So you can see this is a problem where a real industrial multi-phase reactor was solved, or data analysis was done using this machine learning based things, and different type of analysis were done, different type of things were done, and it was presented in a very simplistic way so that each and every person can use it. So this another thing was that this WAVT prediction with the help of dates. So this was a plant and this was the model output. So you can see that why we were doing this, because another objective was that catalyst deactivation. If we are able to predict this catalyst deactivation, then we are going to save a lot for the refinery, because catalyst deactivation is a phenomenon which happens in each and every catalytic reactors. So, and you can see that most of the chemical reactions, they are catalytic. So once we are talking about catalytic reactions, there's, and that too in petroleum refining, more I think nearly all the reactions that are taking place are catalytic. So that's where in case of DS, what was our objective, because all these catalysts, these are fixed bed reactors. Our trickle bed reactors are basically fixed bed reactors. So their catalyst has to be changed. Once the catalyst deactivates, the catalyst has to be changed, and the old catalyst has to be removed, and the new catalyst has to be put in the reactor. So that's where to know that just now after this is the time that we are going to our total catalyst is deactivated. So that's where this clear-cut idea is very important, because it helps the refinery in proper planning of the shutdown, because one unit is not independent, each unit is related to another unit, because the feed is coming from one unit, and sometimes the product is going to some other unit and there's some other units. So it is not just like a block that crude oil is coming and then you are getting the product. So because the chemical engineers whosoever are attending this, they might be knowing that yes, petroleum refining is a very complex industry. That's where you have hydrotreaters, you have hydrocrackers, you have FCC, you have distillation, you have adsorbers, adsorption are happening, heat exchangers are there. So many things are there. So this is how this WAVT and all these things looks like. If you see this data, I think just by visual thing, you cannot identify anything. Whether I can say that just by seeing this data that what is the when will our catalyst will deactivate, I cannot draw inference, such type of inference from this data. So now once you compare this WAVT with the sulfur data from the plant as well as this, you can see that yes, with this sulfur predictions, we can see that this sulfur is also varying with respect to the WAVT, because WAVT and sulfur, they are inversely proportional. If your WAVT is high, your sulfur will be less. But once your catalyst is starting to deactivate, you have to increase your WAVT, but your sulfur won't decrease. That's where it's the cross between this WAVT and sulfur that lets you know. And there are different other things that are considered in when we are trying to say that yes, now overall catalyst has deactivated. So this is how we identified this catalyst deactivation rate. So this is the time on stream. So this time on stream is basically how much day the catalyst has been in operation. So we plotted this time on stream based on the sulfur. So you can see that as we are increasing the time, we are going ahead in the number of days. You can see that the overall sulfur is increasing, And that's where we identify that after some time the catalyst is saturated. So it is not, once, even if you are increasing the WABT, it is not, sulfur is not reducing. So you can see that once this time on stream is increasing, the sulfur of the overall DSDS reactor was increasing. So that's how we identified some criteria for identifying the catalyst deactivation. And that was also just done based on the physics behind the problem, that is the DSDS reactor, the chemical reaction engineering, heat transfer, mass transfer, whatsoever were happening, combined with the data that we got. So we have a machine learning based model, data analysis, and we have our basic chemical engineering, that is chemical reaction engineering. And so combining all these three things, we formulate a way to identify just when our catalyst is going to deactivate. So now a last case study that I am going to talk about is about CFD simulations. So I talked about that, yes, CFD simulations these days are combining machine learning to get the idea that, yes, how we are going to get the efficient as well as the timely simulations of our multi-phase reactor. Because once I talk about the DSDS reactor that I showed in the earlier slides, the dimension of that reactor was in 4 or 5 meters was the diameter, and the length was around 20 meters. Now you can see if you have to simulate that such large geometry using CFD, it is not possible even in the fastest supercomputers that we have. So that's where it will take around 3-4 months to simulate such, and then you never know because whether your simulation is right or wrong. Once you come to that stage after 3-4 months, suppose you find that yes, now your simulation is not up to mark, you have to change the parameters, then you are again stuck, you have to wait for 3-4 months. So that's where there are a lot of things that are being done where machine learning is combined with CFD. So these are the few applications of computational fluid dynamics. You can that is the application of fluidization. So fluidization is used in chemical industries like FCC. Then it is also used in pharmaceutical industry. It is also used in drying, coating, granulation, filtering, and it is also used in energy sector, food processing, biochemical, mineral industry, mixing, biotechnology, and all. So you can see that yes, this is one example of how this mineral processing is taking place, what different types of minerals are doing. And then this is a typical example of fluidized bed, and it's this is the experimental, and this is the CFD simulation that are being done. And similar is the case here, where CFD simulations and experimental things are matched. Now you can see that this is the mixing of the tablets that is taking place. So you can see that CFD can easily simulate the realistic scenarios, but the point is that you just see the dimension of this. These are the lab level simulations that we are doing. Even in doing this lab level simulation, it took a lot of time, and so that's where how to expedite this process of CFD simulations of fluidized bed. That was the overall objective. So in case of fluidized bed, the fluidization is a process in which solid particles behave like a fluid. So in this, heat and mass transfer takes place. Hydrodynamic studies are done to identify different hydrodynamic parameters like solid velocity, what is the gas velocity, solid void friction distribution, and many things. So there are different types of fluidized bed regimes. So because these fluidized bed regimes are very typical to what type of operation or what type of reaction we are going to do or what type of application we are targeting. So like if there is no the gas flow rate is very less. In this case, suppose we're talking about two-phase gas, solid gas fluidized bed. So in this case, first is fixed bed. Once you keep increasing the gas velocities, you get this bubbling fluidized bed. Then once further the gas flow rates are increased, you get this slugging regime, followed by the turbulent regime, then fast fluidization and pneumatic conveying. If the gas velocity is extended and it crosses a certain limit, then your solids will be entrained and the gas will carry away all the solids. That is the pneumatic conveying we are talking about. Then particle classification is another important thing, whether it is delta A, B, or C. Then pressure drops, volume fraction, minimum fluidization velocity, terminal velocity. There are many things which are required for the design as well as the scale up. So we are able to do experiments in lab scale, but the point is that we cannot do experiments in large scale industrial setup. Because given their size, their operating conditions and all, you cannot measure many things in a real industrial scenario. But in a lab scale, you can do a lot of measurements. And the idea is that once you have many measurements, you can develop a CFD simulation. You can validate those things you are using the experimental data, then you can scale it up to a real industrial scenario. But still, these type of things cannot be done in a very quick fashion. So that's when you need machine learning for that. So these are the CFD simulations. You can see that there are different type of CFD simulation that people do. That is Euler, Lagrangian, volume of fluid, discrete element modeling, and all. So this is how there are different type of people are simulating many things using this. So moving ahead, so in case of as I talked about, most of the work that people do is using Euler based simulation, because it is easy to do as in terms of computational, because if you're moving to Euler Lagrangian, each and every solid particle has to be tracked and all, and that becomes a very tedious task to do. So that's where in case of Euler CFD model, two phases are penetrating, continue or absorb. There are governing equation. Then you have some closures for drag, lift, and different things. Then there are different experimental correlations for finding out different types of parameters that are required. As we talked about, this fluidized bed reactor not only operates in one regime, it operates in different regimes like bubbling, turbulent, circulating, etc. So once we solve this CFD model, we solve first the mass conservation equation for gas solid phase as well as the solid phase in case of Euler simulation. So in this case, these are the equation we are going to solve. This Vk is the velocity of the phases, phase K, and Pk is basically the mass transfer from phase P to phase K, if there is mass transfer at all. If not, then we are not going to take this term. And the last term, that is this term, represents the momentum exchange between the phases due to mass transfer. So further moving ahead, so this is the momentum equation that we are going to solve, and I'm not going to get into details of this, so because we are running out of time. So further, we can see that yes, if we take an example. If we take an example of this simulation, that this is the Tagipor's paper that you can refer to. In this paper, what happened that yes, there were simulations were done for different type of drag models and all. So this was a lab scale simulation. This is our CFD simulation that we done. Somehow I'm not able to play the video of the CFD simulations. So the point is that there are different type of studies that are done on the lab scale, but still we are not going. We are not able to scale it up to a industrial scale because of the problem that we face due to the computational costs that are related to it. So you can see now the CFD simulations here. So this is the CFD simulation that we performed for. This is the real experimental data from this Tagipur et al. So we are able to simulate all these things good and easy for a small scale simulations, a small scale lab scale simulations. But once so these are the some model predictions on all that were done using for this different types of drag models and so. And now coming to this machine learning based CFD. So why we need ML based CFD? Because the computational cost is very high and we need to scale it up. So our one problem is the computational cost, the time that is taken. And another thing, once we are going to scale it up, that is the dimension of our setup is increasing. We cannot just use CFD. So, and another thing is to understand the physics involved in it, because as we taking the leverage of machine learning, we can draw some patterns out of our computational CFD. And then for the better utilization of data generated by CFD simulations. So the present approach, that is the conventional approach, is that commercial problem statement, that is commercial solvers are used, and they use basic physical properties of each and every material that is there, then collect constitutive equations, input or adjust parameters in consecutive equations, then CFD simulations are done. If it look good, then it can be used for scale up or not. If not, then we will adjust the parameter. That's why I'm saying that you need to adjust the input parameters in the constitutive equation. That's where if you have to perform a simulation for suppose a very large scale, that's where you have to wait for months or so. And suppose a month or so you are in this loop that it does not look good, the results are not good. Then you have to again go back and you have to change the parameters. Once you are changing the parameter, you again have to wait for very, very long. So that's where you can leverage this machine learning to reduce this overall complexity. So what different type of things is being done, that you take a commercial problem statement, you do data mining with respect to practical properties and fluidization designing AI on data. What is the important with respect to the problem, that is what are the input that are relevant to this problem, then use some existing constitutive equation, use some specific constitutive equation, specific constitutive methods are formulated, then CFD simulation are done. Does it agree with the data or not? If yes, then again different type of data mining will be done. And if yes, then you use it for scale up of the problem. So that's where you are using this AI based data, AI and data mining, different type of things are done to expedite the overall process of CFD with machine learning. I'm just taking an example of Ansari et al. What they did modeling of pressure and volume fraction of fluidized bed reactor using data-driven proxy. The methodology adopted in that case was that 3D geometry and input parameters were taken, CFD simulations were done, and training and testing of the CFD results in ANN. So ANN was used for, and the data was generated using the CFD simulations in this case. And further, what they did, that this was the case, that 2D fluidized bed case was there. This was the solid packing. So this orange color denotes the fixed solid bed, and this is the empty region, and that's the flow of air. And this was divided into different of the grids, and the grid data as well as the local data of the both void fraction, your local velocity, different other parameters were taken for the development of the CFD model, and further it was used to train the model. And in this case, the key parameters were this gas density, volume fraction, particle diameter, maximum packing volume fraction, velocity vector of the gas, velocity vector of solid, pressure field of gas, pressure field of solid, time, location of the boundaries, location to the interface. So that's where, if you see in this case, what we identified, that yes, data mining. So you have, in this case, you have to identify that which parameters are very critical for your modeling and which parameters are not. Once you clearly identify those parameters and such things, then you can identify. So they identify, identified these many parameters. So there, and based on these many parameters, they developed this proxy model using this machine learning. So this was there, they use ANN for that. This for the input, and this for the hidden layer, and finally they were getting this output. And moving ahead, different type of simulations were done, and their proxy simulation, which was using the using a small scale CFD data or coarse mesh data as their for the training, and further it was used for predicting the finer mesh data as well as for large scale geometries. And so they compared it, and based on that, they tried to find out how we are going to do that. So moving ahead, the conclusion is that yes, for this AI ML based CFD, that the task was the modeling and simulation time. The computational time was 3 days on 4 CPU, and data preparation and CFD simulation in this case was 3 days on each case. And smart proxy, that was that it was like this model. In case of model training, it was only 24 to 36 hours. And the generation of the result for new case was 180 seconds. You can say that using this smart proxy database model, that is ANN based model, that thing has been reduced to a very low times. So this is it. So with this, I will end my session. So now, Dr. Agastya, if any questions or anything. You are not audible. I'm not able to hear you somehow. I lost somehow. Hello? Hello?
You're audible, sir. Hello, sir.
Sorry, I'm not able to hear you somehow.
Sir, you're audible, sir.
I'm not able to hear your voice somehow.
Hello.
Dr. Manisha, am I audible?
Hello.
Yes, sir.
Okay, so I was not able to hear. So
Now it is fine, sir.
no, yeah, it is fine now.
Okay. Thank you, sir. Thank you, sir, for a resourceful speech. And definitely the knowledge we gain from the session is going to be fruitful for our work. The professor has elaborated the revolution of artificial intelligence in chemical industries and has imposed the importance of the role of statistic and differentiated the difference between the traditional programming and machine learning. Even more, the basics of machine learning was explained, and detailed note on application of machine learning in petroleum refineries with case study was well defined. So it was really a very good talk, sir. And now the session is open for discussion. And we have already received many questions in the chat box, sir. So if possible, I think you can see, you can answer them. How to scale train data?
The scaling and all, it depends upon the data that you are talking about. So in this case, our case, that sulfur was supposed in the 10,000 range or so. So as I said that we scaled it in the range of 0 to 1. So you have to take what is the maximum data you are getting, what is the minimum size of minimum data you are taking. And it depends upon the how many number of parameters you are taking. Because in our case, suppose for the DSDS example, we were taking the sulfur that was in the range of 10,000. Then we are talking about temperature that was in the range of 350 or so. And then we are talking about density, the density that was in the range of few hundreds. So we did scaling based on that, the maximum and minimum, how we are going to do. So it changes from problem to problem, but we scaled it from 0 to 1 in the range of 0 to 1 in our case.
So another question is how to do data cleaning.
So as I said, the data cleaning for realistic data cleaning, for an example that we are talking, we have gathered for what this FDP is about, this artificial intelligence in chemical engineering. As I told that, yes, once you are dealing with the data in problems that a chemical engineer has to take, that's where you need to have a clear-cut idea of the physics of the problem that you are talking about. As I said that we set the metric for this data cleaning. Suppose in case of sulfur, if our feed sulfur is 10,000 ppm, so definitely at any point of time, it cannot go beyond 10,000. If it is going beyond 10,000, it means that there is some noise in the signal that you are getting. So we totally eliminated, filtered that data. Similar was the case of temperature and all. So it cannot go beyond a certain level. It cannot go beyond above a certain level. And then that's where we also try to measure this standard, try to track the standard deviation that we got. If it is going beyond a certain level, we did some filtering on that. So there are some statistical ways as well as some physical way of reducing this data filtering. So this is what we are going to do for that.
Okay, so next is which tool is used for this ML model?
Pardon? Can you repeat?
Which tool is used for this machine learning model?
Tool is that there are if someone is starting in this, you can refer to Python. There are different type of data filtering and things that are inbuilt in that you can use for that data filtering and data cleaning. So you can directly use for that.
Okay, so next is IFS, input future selection and data filtration similar?
Pardon me, can you repeat somehow your word?
IFS, input future selection and data filtration is similar?
No, they are different. They are different.
How to do prediction with testing data after training data model?
So this training and testing data, as I said, that every time you have a pool of data, you have to divide your total data, whether it is 70 to 80 ratio or 80 to 20 ratio, you divide 80%, suppose take it for your training and 20% for your testing data. And another thing that you have to take into consideration is that you don't choose the data just by any method. Also, you have to do the selection of the data, random selection you have to do, so that you cover the overall gambit in your both training as well as the testing of the data. So you train your model with the 80% of the data, and based after that you do testing on your remaining 20%. And then you also have a validation. You should also have a validation data, because once you have model is trained on training data, and then it is tested on your testing data, then you have to validate is using a validation data. That's where you need to have a clear-cut idea that, because in our case that we took the sensor data and divided it into training data and the testing data. We took the lab data as the validation data. because lab was also doing this measurement. Sensors were also recording the data. So that's when we took this lab data as the validation data. And now you have to, because you have to take a wise decision how you are going to divide this data into training, testing, and validation. And it should totally correlate with your problem that you are solving. Because don't just take this data as a black box. Don't treat this. I'm just restating this point that don't treat this machine learning as a tool, because if you're just taking it as a tool, it is a sort of a black box type of thing that will just give you some result, because if you pour in some input, it will give you some output. So that is my suggestion to everyone.
How to do data cleaning in Excel?
So data cleaning in Excel, suppose as I told you that if you set the metric, if your metric is that suppose we are not going, standard deviation of some sort is not acceptable. You can just set, you can calculate the standard deviation in Excel. You can identify that thing. You can remove that data. Or you suppose if some noise, you can easily identify that, yes, if the data goes beyond a certain level, yes, that is definitely a noise. I will eliminate that data. So this preliminary data cleaning or data filtering can be done in your Excel as well, because finally all the codes and whatever you are going to use, they are based on some mathematical method, and they usually can be done in Excel.
Is the predicted results were matched with real plant production data?
Yes, everywhere, whatever slides you are seeing, those were the real plant data, and they were matched with the real plant data.
So do we need to do error analysis based on real plant production results?
Yes. So every time, whatever the root mean square error, whatever statistical parameter you are going to take, so that those parameters we took based on the plant data only. So that was the different type of error analysis we took.
And then how were this predicted data used commercially by industries?
So commercially, as I told you, that these type of models or these type of things are coming up in the chemical industry, because chemical industry as such is picking up with this type of things. So many startups, many companies, and now you will see that all the petroleum companies or the PSUs, they have now a data analysis team. They have a SBU for this business units for this data analysis and all, because they are also knowing that yes, now this is the next big thing and they should not be behind. So that's where their teams are there. They are working on that. They are also interacting with the academic institutes and that's where these models are being developed, and it is installed in their refineries, so that they're based on graphical user interface. Their process explorers are connected with it so that they can get the maximum out of this.
Okay, DHTS model being shown seems to be Aspen Plus. Is it so like that they have asked? What
it is not Aspen Plus. So DSDS is basically a lot of simulations can be done in DSDS, but here all these things were the real data, the tag data that were taken from the refinery.
So the same question, like relevant thing, how we can predict the data are updated and real time.
So that's where you need to you need to write your code in, because this process explorer is something where your data comes, whatever the sensor are recording the process explorer, it takes the data. So the process explorer is from Aspen. So they have a I will say extension method by which you can extend it to your MATLAB or Python. It can be extended to that, and it can be directly linked. So that's where you can take the data from the Aspen Process Explorer directly into your ML based model that you have developed, and that's where you can real time you can do predictions.
So what is the role of bias in ANN?
So bias is basically, if we are just doing a one-dimensional regression, that is y equal to mx plus c. So you are just fitting y and x with a line. So you have x and y, and you want to fit a straight line, suppose, into that. So that is the equation we get is y equal to mx plus b. C, m is the slope, and b is the intercept. So c is the intercept. So basically b in somehow signifies that, because once we are talking about machine learning, and that's where the input vector is not in one dimension. It can be 3 dimension, 4 dimension, and 5 dimensions. So the bias just is a sort of representation the C represents in case of 1D regression.
Okay, still more questions, sir. What is the basic language we should know for applying AI and machine learning in chemical industry project?
So for that, because MATLAB has all the capabilities that you can see, but the point is that if you have good command on Python, that is better because Python is something that is free. You don't need to have license. And Python for data analysis and for machine learning is a best tool right now, best thing.
And how do we get the real time data from industries like petroleum refinery for machinery learning? Will they provide?
So it is very difficult to get the real time data because you need to have collaboration with the industry because they are not going to share their data as such.
Is data generated by AI is accepted by regulatory bodies?
Yes, now it is now definitely now definitely because that's why I showed you different type of examples where different types of the leading petroleum companies they are talking about different types of AI based models, and so that's where it is very important. So they are not taking it seriously.
So now the session is open. If anybody wants to ask direct question, you can raise your hand. I think so. You have already elaborated all the doubts already in this chat box. So many questions have been cleared. So thank you so much, sir. Thank you for.
Okay, thank you for giving me the opportunity. So I thank everyone, the organizers, as well as the listeners, as well as the participants, everyone, as well as the college for giving me such an opportunity. As well as I thank the AICT for such a wonderful program where each and every faculty can share their inputs and we all can learn from different types of talks. And
okay, sir.
Also thank the organizers for selecting such a topic because it's a very new topic and that is the emerging topic and where the chemical engineering has to pick up a lot. So thank you for arranging such a talks.
Thank you, sir. Thank you so much.
Thank you.
Participants, please kindly fill the feedback form. So it is very mandatory for the final exam. So we need like 80% of attendance. So it is counted. So kindly fill the feedback form. And next session starts by 2 p.m. sharply for wellness through Sahaja Yoga meditation. So kindly join sharply by 2 p.m. Thank you.
Good afternoon, sir.
Good afternoon, ma'am. Hope my voice is clear.
Yes, sir, it's clear. Sir, we'll wait for 2 minutes, sir. Let participants join the session, then we can
Yeah.
start.
Will it be possible to allow me to check the audio video connection?
Yes, sir, sure. Sir, actually, video is visible.
Yeah, I will just try to share the screen.
Yes, sir, sure, sir.
Let me know if my
Yes, sir, it is
audio is
visible.
everything is okay?
Yes, sir, fine. Good afternoon, sir.
Good afternoon, ma'am.
Good afternoon, everyone. Welcome back for the session 3 of first day Atal sponsored 1-week online faculty development program on data science and artificial intelligence in chemical engineering, recent trends and future outlook. Stress is a vital part of our job. It is common and unavoidable in the workplace. Research shows that over 87% of employees worldwide are emotionally disconnected from their workplace and less likely to be productive. The best way to manage stress is to understand what stress management is and how to handle workplace stress. For all this information and knowledge, we have with us today Chandrakant Dioda sir for the present session. Chandrakant sir, working as Senior Technical Delivery Manager with Western Corporation Private Limited, Pune. He completed his post-graduation in Electronics and Instrumentation Science from University of Pune in the year 2004. With a brief stint in technical sales markets, Chandrakant sir has been largely associated with software and IT industries in India, USA, and Japan for last 15 plus years and have worked with various Indian and foreign companies, including Wipro Technology, Johnson Control, Toshiba, etc. Chandrakant sir have been associated with and voluntarily conducting the Sahaja Yoga meditation programs and classes free of cost with various government organizations, colleges, schools, and private sector companies. Without further delay, with immense pleasure, I would like to invite Chandrakant sir to start the session on wellness through Sahaja Yoga meditation. Over to you, sir.
Thank you, Dr. Chitra ma'am, for this warm welcome. And as you suggested, the stress is a very important factor in our day-to-day life. If we didn't handle the stress, it will kill our future. It is an entry gate for all kind of problems, all kind of disease. We need to handle the stress properly. And wellness is another important factor. If you are well in each part of your life, you can do a wonder in your life. You can achieve a success. And for that, we all are here. So this session will be around 1 hour, where we will have a theory part around 10 to 15 minutes. Then we have a practical part. Then we have a question answer and how to meditate. So on this journey with me, my colleague is there, Bhagyashree. So Bhagyashree ma'am is from the Karnataka. So welcome Bhagyashree ma'am. And also Advocate Atiti ma'am is also there from Noida. Hope both are there. Yeah, welcome Bhagyashree ma'am.
Good afternoon, ma'am. We welcome you for the session.
And Advocate Atiti ma'am is also there from the Noida. So let me share the screen. So I request you all participants, feel free to interact with us. Consider this session as more or less, it's a fun session. It's like we are learning something new that will change your entire life. So we all are here. We all are here to enjoy this session for around 1 hour. I guess there is some problem facing by Advocate Atiti ma'am. So maybe Atiti ma'am cannot able to unmute herself. So please give the access so Bhagyashree ma'am and Atiti ma'am can unmute themselves.
Yes, sir. Yes, sir. I'll just check it, sir. 2 minutes.
Anyway, we can start till the time you can give the access. So today what we are going to learn is a simple, very effective method which we call as a Sahaj Yoga meditation that will going to change your entire life. That will going to change the thing.
Excuse me, sir.
Yes.
Sir, I think now ma'am can access.
Okay, thank
Aditi
you.
ma'am and Bhagyashree ma'am.
Yeah, thank you very much, ma'am. Yeah.
Thank you, sir.
So let's start the session with a simple interactive part. Let's understand what is meant by yoga, because today we are going to learn a yoga, a simple method which we call as Sahaj Yoga. So before we go to the Sahaj Yoga, let's understand what is a yoga. So anyone want to share his thoughts or anything, whatever you know about yoga? I am looking for the perfect definition of yoga or a very simple meaning of yoga. Anyone want to share? Anyone want to share what is mean by yoga? You can use your chat feature or you can unmute yourself, whichever is comfortable for you. So what is mean by yoga? Okay, so Nikita says rightest knowledge. Maybe it is little true, not 100%, but yeah, it is true. At some sense, it is true. What else? Anyone want to share? So thank you, Nikita. At least you started the thing. Right action. Okay. Yeah, that is also true, ma'am. Little bit, but not 100% correct. So what is exactly meaning of yoga? Anyone want to share? Okay, so Chitra ma'am says state of body and mind. Shamila ma'am says exercise of mind and body. So, okay, let me explain you. So Dr. Ramakrishnan says knowing about self. So the word yoga come from the Sanskrit word called yuj. Yuj means union. So union between your own energy with the cosmic power. So your own energy, then you will ask the question, where is our own energy and how it will get connected to the cosmic power. So our own energy is located at our sacrum bone. That is, if you see this human body, in human body, there is a triangular bone. Inside that triangular bone, there is a spiral form of energy, which we call as a kundalini. That energy exists within you. And once that energy get connected with the cosmic power, that time you get your yoga. That is the real meaning of yoga. And under this yoga, there are all different kind of method come. So now you will going to ask the question, this energy when this energy, how, what is that energy, when this energy came to our body, and who created this energy, and what are all questions like this energy exist only in male, or it is exist in woman also, or it is exist in a kid, or it is exist in an adult. So there are many questions. So let's understand the answer of all these questions with small video. So let me show you one small video. So this energy, at what time it's entering in our body, that I will be going to explain you with this small video.
When the fetus is about 2 to 3 months old in the mother's womb, columns of rays of consciousness pass through the brain to enlighten it. The shape of the brain being prism-like, the column of rays falling on it gets refracted into 3 diverse channels, corresponding to 3 aspects of our nervous system. The right sympathetic nervous system or Pingala Nadi, the left sympathetic nervous system or Ida Nadi, and the parasympathetic nervous system or Sushumna Nadi. This subtle energy enters through the centers in the brain and precipitates on its way to 6 more centers called chakras, which is also called plexus in medical science. The residual energy then settles down in 3.5 coils in the triangular bone, medically called the sacrum bone, placed at the end of the spinal cord. This energy is known as Kundalini. The fundamental of this living force is self-organization, self-regeneration, and ascent. Through self-organization, it sustains and protects. Self-regeneration is its innate ability to renew, heal, balance, and recycle. Ascent is its capacity to transcend the mind and myth and attain collective consciousness.
So this is the meaning of yoga. Now we understand when our energy get connected with the cosmic power, that time the yoga will happen. And now we also understand this energy, how is created in our body. But now, once this energy is activated, what are the benefit we get, or what are the wellness we get? So if you see, a wellness is divided into 8 major parts. One is the emotional, spiritual, intellectual, physical, environmental, financial, occupational, and social. So if all these 8 factors is balanced, your wellness is properly balanced. So one of the important part is emotional part. So many times you will observe that you are emotionally attached to the one person, one family, one particular thing. But when you spiritually grow, when you do a yoga, you develop the emotional intelligence, you develop the emotional balancing within you, and that will help you to be a master of your emotional thing. Once the yoga will happen, you grow spiritually. Your spiritual level will increase drastically. So your emotional level will improve. So your EQ will improve. Your spiritual level will improve. That is your SQ parameter will improve. Then your intellectual thing also improve. So EQ, IQ, and SQ, all these 3 parameters will be drastically improved in your day-to-day life. With this improvement, you will see a lot many problem will solve automatically. You have a confidence, you have a very good communication skill, you have a decision power, you have a problem solving power. All things will come into the right direction once you develop these three things. Then fourth thing will come as a physical thing. So you have any kind of disease, any kind of imbalances, because in every person there is a different kind of body and each has some kind of disease, some kind of physical problem. So but when you do a yoga regularly, you will find all your physical problem will solve naturally without taking any medicine. If you take any medicine, each medicine has some kind of side effect, but the yoga is a natural method to resolve all your physical problem without any drawback, without any disadvantage. So this is the real method. Okay, so my voice is low, so should I increase my voice? Now it's okay? It's okay, hope my voice is now clear. Okay, so now if you do yoga, you will observe that all your physical problem will get resolved naturally without without any drawback. You will see the environment near to you, or maybe wherever you go, you will always create a peace, you will always create a blossom, you will always create a happiness surrounding to you. So this is also a good quality which you will develop. You will observe that you will also develop a good financial balance, because once you develop EQ, SQ and IQ, the money will automatically come to you. You will be more creative. In each sector, you take a good decision. So in your service, in your society, in your social network, you will find a lot many benefit once you start doing the yoga. So these are the main benefit you will get once you do a regular yoga. So now let's understand how all these things will develop naturally within us. So you know, when I have just explained our body structure. So when a baby get the birth, he has two eyes, two legs, nose. So this is his physical body. But at the same time, its internal body system is created that is made up of nadis, chakras, and one special energy which we call as a kundalini. So just now we see the how kundalini is activated. But let's understand this blue color line. This blue color line which we call as the left sympathetic nervous system, or which we call as the Ida Nadi. So once this is the channel of our past, this is the channel of our desire. Yellow color line which we call as the right sympathetic nervous system, or a Pingla Nadi. This is the channel of our future thinking. This is the channel of our action power. And the center path which we call as the Sushumna Nadi, or a parasympathetic nervous system. On this channel we have a 7 energy center. This energy center is nothing but we call as a chakra in Sanskrit, and this is a bunch of cells which control our different body organ. But now the question is, why I am explaining to this to you? What is the use? Why we are understanding our internal body structure? So let's understand the first part, left sympathetic nervous system, that is Ida Nadi. So if person has some kind of imbalance in his left side, that is Ida Nadi, so he will always feel a lethargy. He will always focus on his past. Is over emotional person. You always feel a depression and loneliness. If you find this kind of characteristic in any person, then you can think that this person has some kind of imbalance in his left side, or maybe he's weak, he has a weak left side. Similar way, if you find a person who is overactive, or maybe always thinking about future, workaholic, aggressive, angry, or a dominating kind of person, you will see lot many this kind of people. So you can understand that there is some problem in his right side, or his right side is a weak. But the person whose left side and right side is properly balanced, that person we call as a balanced person, that is stay in a Sushumna Nadi. He always think positive. He is a very peaceful person and completely balanced personality. And today, with the help of yoga, with the help of Sahaj Yoga technique, we are going to achieve this method, which we are going to balance our left side, we are going to balance our right side. Once you balance your left side and right side, you see that you will always be in the balance. And to achieve this balanced state, this is the key feature of Sahaj Yoga. Sahaj Yoga make you that you should be always in a balance, not go toward left, not to go toward the right. So let's understand how this is exactly happen. So I will going to show you one small video. Let's first see that video and then we will discuss little more.
Sa means with, Ja means born. So it is born with you the right to become united, which is the yoga, with the divine. We have two sides in our system of autonomous nervous system, left and right, which we call as left and right sympathetic nervous system. The left side caters for our emotions, for our past, our desires. The right side caters for our action, physical and mental. If you indulge into one too much and go too far with it, you develop an imbalance within yourself. In the center lies the third power, which we call as parasympathetic nervous system. This is the channel which is the central path of ascent. When the Kundalini rises through it, it brings you in the balance because it rises in the center of the system. So this is the minimum that happens, that you develop your balance. This is the last breakthrough of our evolution, where you have to get connected with the divine. You have to feel it on your central nervous system, and that's how you get your self-realization.
So this is how a small video I have played. This video belongs to the founder of Sahaj Yoga, Dr. Sri Nirmala Srivastava. So now, as explained by Her Holiness Shri Mataji, this is left side, right side balancing as well as 7 chakras. So these are the 7 chakras which is located in our body, and these 7 chakras controlling the different part of our organ. For example, Nabhi chakra controlling the kidney, pancreas and stomach. So how this energy get activated and how it clear all these imbalances, let's see in a small graphics. So this is our human body. When we do today some practical, that time what will happen? The energy which is located in a sacrum bone, that is the triangular bone where we are sitting, that place we have that energy called Kundalini. That energy get activated because it's in a passive state. Once we do practical, it get activated and it goes to the first energy center which we call as Muladhara. That energy center control our reproductive and excretory organ. If you have any issue with this organ, by just meditating on Muladhara, you will be able to resolve the problem. Slowly, then it goes to the next energy center, which we call as a Swadhisthana chakra. You have heard many times those people doing a meditation or yoga, their memory power is tremendous. They are very creative. But what is the science behind this? Once this energy reach there, this energy center will create a gray cell, and that is required for our brain. That is why people will those people doing a meditation, they have a very good memory power, they have a very good creativity, awareness and attention. Then slowly it goes to the Nabhi chakra. From Nabhi chakra it goes to the Hriday chakra. From Hriday it goes to the Vishuddhi. From Vishuddhi it goes to the Agya, and from Agya it come out from the Sahasrara. Once this energy come out from the Sahasrara, you get the thoughtless awareness, that is Nirvicharita. The state where you do not have any thought, you are completely zero thought, you are completely in a balanced state, neither in the past, neither in the future. This is the state which we call as a shunya shikhar. In many books you have understand that shunya shikhar or a zero state. So that state we are going to achieve. Even if you achieve this state for 1 minute, that is a great achievement. So now how this state we can achieve, that is we are going to do with the practical part. But before that, who invented this method, why this method is invented, who is the founder, and all this stuff we will going to learn. So this method is rediscovered by Dr. Sri Nirmala Srivastava in 1970, where she combined the spirituality together with the science and rediscovered the technique called as self-realization, that is Atma Sakshatkar, that is awakening of our Kundalini power. So previously this method also, this method is exist in our past also. But what happened, one master used to give this knowledge to one disciple, and that disciple used to go into some forest. He or she sit in some forest for years and years, totally disconnect from the society. But after 1970, Sri Mataji developed the en masse meditation or en masse realization concept. For with this concept, you don't have to go to the mountain, you don't have to go to the forest, you don't have to disconnect from the society. You can still be in your home, you can still do meditation, still awaken your energy and be a part of society. So this is the great invention or a great development in 1970 at Nargol, that is a place in Gujarat. And after that, Srimataji traveled across the world, and today I can proudly say the most practiced yoga in the world called as Sahaj Yoga, and it is totally free. I remember one important statement from the Srimataji that you cannot know the meaning of your life until you are connected to the power that created you. And today, with the help of practical, you will able to achieve that experience. So what you will get from the today's session is the experience of freedom, experience of liberation, experience of Kundalini awakening, experience of inner joy that you cannot get in a book, you cannot get in a Google or any social media. But today, when you do practical, you will able to feel a cool or a hot breeze on your palm. You will able to feel the joy. You will able to feel the peace, and that experience with you throughout your life. You may not remember us, you may not remember this PPT, but you will remember the experience which you will get today. And because of this experience, you will see it will change your life. If you follow the technique properly, regularly, you will see this is the session which will change your life. This is the session will be the change point in your life. This is the session which will start the success line in your life. So what we are going to do, we are going to experience this thing in a practical part. So the practical part is very, very important. If you give your 10 minutes with 100% concentration, 100% attention, you will see a real meaning of yoga. You will experience the real meaning of yoga. So now we have 8 steps, and this 8 step I will request my colleague Advocate Aditi to explain, and with the video we are going to take this experience from the Dr. Sri Nirmala Srivastava. So I request my colleague Advocate Aditi. She is from the Noida. She can explain these 9 steps. So I will request ma'am if you can explain this 9 step. Okay, Advocate Aditi ma'am. Chitra ma'am, can you please unmute Advocate Aditi ma'am if possible?
Yes, sir. Ma'am, now it is unmute, ma'am.
Yes, yes, sir. Yes, ma'am.
Welcome you, ma'am.
So we will now begin. I will now just quickly explain the 9 different steps.
Excuse me,
So
ma'am.
for all, yes, yes, ma'am.
Ma'am, the voice is a bit low. Can you please?
Okay, okay, ma'am. All right. Is it better now, ma'am?
Now it's okay, ma'am.
All right. So so these 9 steps are very, very simple. And for the first step, we can, in fact, for all the 9 steps, you can see that on the screen, the diagrams which are on the screen, the left hand is on the lap continuously. And it is just the right hand which is moving. And so there is also a very scientific reason behind this, because our left channel is the channel of desire. So the left hand will be kept on the lap, and our right channel, which is the channel of action. So with the right hand, we will be doing the different 9 steps. Will be moving. Only the right hand will be moving to in all these 9 steps. Okay. So for the first step, we have to keep our left hand on the lap, and right hand will be on the heart. Then for the second step,
The left hand again on the lap, palm open. The palm of the left hand to be kept open, continuously to be kept open, no fingers to be closed, and right hand to be placed on upper part of abdomen. The upper part of stomach on the left hand side. So right hand palm, we will keep it on the left side of the stomach, upper part of the stomach. Now third step, again left hand on the lap and right hand palm on the left side of the abdomen, lower abdomen. Now fourth step is again repetition of second step. Right hand again on the upper part of the abdomen, left side of abdomen. Fifth step, we will take the right hand palm on the heart again. Fifth step is repetition of the first step. For the sixth step, we will take the right hand palm towards the left side of our neck and shift our head towards the right hand side. So we will take our right hand palm, I'll repeat it, we'll take the right hand palm on the left corner of our neck and shift our head towards the right side. Seventh step, right hand palm on the forehead. Right hand palm is to be placed on the forehead. Eighth step, right hand palm at the back of your head. So right hand palm will be placed at the back of your head and we have to press the head slightly at the back. And ninth step, which is the last step, we will take the right hand palm. Center of palm, we will keep it on the center of our head. And we will rotate our palm clockwise. And when we are moving our hand clockwise on the head, automatically our scalp will also be moving. So I'll just repeat the last step. Ninth step is right hand palm, center of palm to be placed on center of our head. And we have to move our hand in the clockwise direction. So our scalp will also move in the clockwise direction. So these are very, very simple 9 steps. And we can be either seated on the chair or we can be seated on the ground, whatever is comfortable. If we are sitting on the chair, then it is better if we can keep our feet directly on the Mother Earth. So we can remove the footwear, keep the feet directly on the Mother Earth. So this will help us because the Mother Earth, the gravitational pull of the Mother Earth will absorb all the imbalances from the feet, the sole of our feet. So we will, so next we will be now seeing, we will now be taking our self-realization directly from Her Holiness Shri Mataji Nirmala Devi. And so we request all participants, it's just 2 to 3 minutes video. It's a very, very important, it's the turning point in everyone's life. It's like a second birth. It is the second birth of everyone when the Kundalini gets awakened. So please do it with utmost sincerity. We can keep our mobile phones on silent mode so that we don't get disturbed. So we will now view the video.
Keep your eyes closed. First of all, please put your right hand on your heart. All the time, the left hand is towards me. Now, here you have to say, in your heart, with all sincerity, Mother, am I the spirit? Ask the question 3 times in your heart. It's a very fundamental question. Now bring the right hand on to the left hand side of your stomach, in the upper part. Here press it. Now this is the center of your mastery, your guidance. your Guru Tattva, as they say. So ask a question, Mother, am I my own master? This is a question to be asked 3 times. Mother, am I my own master? Now, bring your right hand down below, in the lower part of the abdomen. Now, this is the center from which all the divine work is done. All the pure work is done. So to ask 6 times, because this center has got 6 petals. Mother, please give me pure knowledge. 6 times you just ask. As a result of this asking, the Kundalini starts getting awakened. Now to help the Kundalini rise, you have to cooperate with her. So please put your right hand on the left hand side in the upper part of your abdomen and press it on the stomach. Now here you have to say with full confidence to help the Kundalini to rise. Mother, I am my own master. This you have to say 10 times. These are the 10 commandments which you have to say. That, Mother, I am my own master. Now, 10 times with full confidence. Now, please raise your right hand to your heart. Now, here you have to say, again with full confidence, Mother, I am the Spirit. This is the truth. You are the Spirit. But you have to say with full confidence, Mother, I am the Spirit. This you have to say 12 times. Now one has to know that God Almighty is the ocean of love. But above all, He is the ocean of forgiveness. So He forgives. Whatever wrong you do, He forgives. So don't feel guilty and put your right hand across on the left hand side in the corner which is made by your neck and your shoulder. Now here you have to say, again with full confidence, 16 times, Mother, I am not guilty. Please say it. Mother, I am not guilty. 16 times. I am not guilty at all. Please say it. Please say it. Very good. Now raise your hand across on your forehead. And it's a very important center. Here you have to say from your heart, Mother, I forgive everyone. Please say it from your heart. How many times is not the point? Mother, I forgive everyone. Now, some would say that it's very difficult to forgive, but it's a myth that we do not forgive or we forgive. We do not do anything in both the cases. But if we don't forgive, then we play into wrong hands. So please say from your heart, Mother, I forgive everyone. Now please take your hand on the back agya, the same center, on the back side of your head and allow your head to rest on it and push it back a little bit. Now here, you have to say, for your satisfaction, because you always feel guilty, that, O Divine, if I have done anything wrong, please forgive me. Please forgive me. From your heart. Stretch your hand fully and put your center of your palm on top of the fontanelle bone area, which was a very soft bone in your childhood. Press it hard. Press hard your scalp. Now you have to move it 7 times, saying one thing, which you have to ask for. Mother, please give us my self-realization, because I cannot force on you. So you have to ask for it. 7 times, press it hard and move it 7 times, very hard. Slowly, saying that.
Now slowly take your both the hand on your lap. Our eyes should be closed. Spinal cord should be upright and straight. Be in a relaxed position. We are going to do a meditation for few seconds. Don't do any movement in your body. Be relaxed, just concentrate on top of your head. Now slowly we can open our eyes, very slowly. And the last step, which we all going to perform together, is raise your right hand on top of your head like this. Move little up, down, left, right. I request you all participant, if you possible, can you please switch on your video for just 1 minute? We all will be going to perform this step together. So I request you all the participant, if possible, please switch on your video. Raise your right hand on top of your head. Move little up, down, left, right. See if you can able to feel a cool or hot breeze. You can feel that energy. You can see my video or you can see the Bhagyashree ma'am's video. Now take your right hand back to your lap. Try with the left hand. I request you, if possible, all can start their video just for 1 or 2 minutes. Move little up, down. So thank you, Ganesh sir. Yes, you are doing perfectly right. Move little up, down, left, right. See if you can able to feel some cool or hot energy above your head. Now take your left hand back to your lap. Again, try with the right hand last time. See if you can able to feel that energy. It's a cool or it's a hot. Yes. So yes, Krishnamurthy sir. Yes, you are doing perfectly fine, sir. Thank you. Now you do namaskar, the pranam, the way we used to do pranama. This pranam to our internal energy, that is our Kundalini mother. And slowly we can open our palm like this. Move forward, move reverse, forward, reverse, forward, reverse. Did you feel some kind of energy between your palm? So what about Krishnamurthy sir? Did you feel some energy? What about Ganesh sir? Did you feel? You can say yes or no. Did you feel some energy? You can share your thoughts, or you can share the thing whichever is comfortable for you. Feel some kind of energy. Okay. So thank you very much. Now maybe you can switch off your video if you want. So this is the part of self-realization, that is our Kundalini is awakened today. And after this awakening, you feel this cool or hot breeze on your top of your head and both the palm. Now I will going to ask you, feel free to ask any question you have, where if you have any question like diabetes, blood pressure, aging effect, eye problem, immune power, or any emotional problem, anything, whichever problem you have or your family member have, or if you have any clarification, feel free to ask. So myself, Bhagyashree ma'am and Atiti ma'am is here to take your question. So feel free to unmute yourself or post a question on chat. But till the time, I will request Bhagyashree ma'am to please explain how to do meditation at home, at what time we should do meditation at home, and how much time we should do meditation at home. So Bhagyashree ma'am, can you please help us to understand this?
Thank you, brother. Yes. Sahaj Yoga is an effortless meditation and it's very easy. You can do it for 10 to 15 minutes in any time of the day. And usually if you start with meditation throughout the day, you feel more balanced and stress free, because early morning it is so quiet and calm, and you will not be having much thoughts. So that time you feel much relaxed, and you feel more energized. And whenever we feel stressed up, we can practice it in any time when we get some leisure time or in the evening. And every day to continue this meditation will give us ascent, and this is the last breakthrough of human evolution, where our growth and ascent, we come into balance and we feel the vibratory awareness. Because today what we have felt a little bit of energy, and since in this hectic life we are more using our second plex, or that is swadhisthana, which works very much in the in a body. We feel more heated, and we use more brain because we are using lot of technology, and we are used to with so many machines, and this machinery life somewhere it is removing or replacing lot of our physical exercise, and this and the food also it impacts a lot on our body, and that's why lot of changes will be going on throughout our body. So this meditation will give balance, overall balance, and makes us stress free. When we are stress free, we take good decision, and this meditation helps us to improve our personality and stay calm, and helps to take right decision. So very few simple steps what we learn in this process of meditation, it really helps to remove and relax all the unwanted disturbance which is happening within our mind, and which in turns affects our organs. So that we will be learning in further sessions. But meditation, you can, this is a very simple and effortless meditation, and it is a spontaneous thing which is happening within us, and we can practice throughout the day, and anytime you can do it. If you have any questions, you can ask. All age groups can do, and it's there is no condition that you should follow such a hard task to do it. Only the main thing, you have to have the pure desire to continue this meditation. And once you start enjoying this meditation, you yourself will feel so much calm and relaxed in yourself, and you like to do whenever you feel imbalance. So do you have any other questions you can ask? We focus so many things on physical aspect, like doing exercise, everything. For example, when we do exercise, like our breathing, our heart rate, it increases. We get exhausted. Again, there's something which brings us into balance, that bring it into a normal condition. Like that, in our day-to-day life, there will be a lot of things like anxiety, stress, worries, workload, and sometimes we'll be unable to manage our home and office work. So many things we may carry in our mind, from home to office and office to home. So that really creates an imbalance, and it affects our work environment, our performance. So when we practice this meditation regularly, then we come into balance. Then the all the things whatever we want to do will be effortless, and we stay calm and happy in throughout the day of our life, and we interact very happily with everyone. So, Sahaj Yoga improves us and gives good health. And if we are having any diabetics, or a high blood pressure or a low blood pressure, if our hemoglobin rate is not okay, then this meditation will improve that. And we have seen lot of things which we have benefited through this meditation, and that's why even in throughout the world it is being practiced. So if you have any doubts, you can ask. Okay, over to Chandrakant sir.
So Okay, so thank you very much, Bhageshri ma'am. And we have posted one feedback form. If you fill the feedback form, you will get the, today's PPT. Also, if you want to learn more, you can join the WhatsApp group. So I posted a WhatsApp group link also in the chat. So I'm getting some private messages about the different problem. So there is a question from how to resolve spine related problem. So spine related problem can be resolved with 100% thing, with 100% accuracy. Only thing you need to do a regular meditation. When you do regular meditation, you will observe that your spine will get correct, or it will straight out. Or it naturally it will correct your spine when you do meditation. And because of that, you will observe that all your spine related problem will get resolved in 15 days only. But the key is you need to do meditation every morning and every night before you go for sleep, and every morning 10 minutes you need to start, and you need to go around 20-25 minutes. If you do this regular, you will see your all spine related problem will resolve without spending any money to doctor or any medicine. It's a natural method. Ma'am, please try and let me know. So there is one more question. In the process of Kundalini activation process, is there problem arise like constipation? No, 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 no. This is totally wrong understanding. When the Kundalini is awakened, if you have a constipation problem, it will resolve. It will resolve completely. Your digestion system will improve. Your power of digestion will improve. Your stomach will improve. Your pancreas, liver, it will all the organ will function, will work very properly, and the immune power will also improve. So no constipation. Even if you have a constipation problem, it will resolve. So thank you, very good question. Now Sakshi Batra ma'am is asking question. Thyroid problem can be resolved using meditation? Yes. So thyroid is located on this part. If you do meditation on the Vishuddhi chakra, that is Vishuddhi chakra is controlling the thyroid. So this is the place. So what you need to do, 10-minute meditation, and then raise your right hand and put on your thyroid here and do meditation, and just take a prayer. Mother, please clear my thyroid problem. Mother, please balance my Vishuddhi chakra. These are the two prayer you need to take, and keep your right hand here for just 2 and 3 minutes, and you will observe that your thyroid problem will slowly go away within a 10 to 15 days. Generally 10 days you will observe a little change if you do regularly. Okay. So thank you very much, Chitra Sakshi ma'am, for a very good question. There is one more question, sir. What are the physiotic episode? Okay, I didn't got the question properly, but I think you want to say the psychosomatic disease. That is what, if I understand correctly. So psychosomatic disease is a broad category of disease. That is the left-sided disease. If you do regular meditation, so meditation is the only way, it is the only one method which will resolve all type of psychosomatic disease, because this is coming from the left side. So what you need to do, keep your left hand on your lap and right hand on Mother Earth, and just pray, Mother, please clear my left side. So I can quickly show you this method over the PPT also. So this is a PPT where what you need to do is you need to perform this method. This is the clearing of left side. So what you need to do, just keep your left hand on your lap and right hand on Mother Earth, and do meditation for 5 minutes. If you do it properly, you will see all your psychosomatic problem will resolve. Okay. There is one more question okay, can POSC problem also cured? Okay, I don't exactly understand what is a POSC. If you expand little more, I can. Okay, okay, yes, yes. So now I understand. So yes, ma'am. This is related to Muladhara chakra. This problem. Yeah. Okay, I understood the problem. So this is related to Muladhara chakra, that is a base chakra, first chakra. So the Muladhara chakra is controlling all your reproductive and excretory organ. So what you need to do, you need to meditate every day along with foot soak. The foot soak technique, which we didn't explain to you right now, you need to do foot soak technique every day for 10 minutes, and which you will observe that this problem will cure naturally. So what is the foot soak technique? I can quickly give you a YouTube link. You can just go on a YouTube link and check the video on foot soak, and you will able to perform the same thing at you can perform the same thing at your home, and you will able to cure this issue. Share that video, YouTube video. Just give me 1 minute. Thank you, ma'am. This is very beautiful question because you have asked. That is why we could able to give this video to you. So this is a foot soak video. You can practice at home. It's a very simple step. Okay. Thank you. There is another question, sir. Can remote arthritis can be cured? Yes, arthritis can be cured 100%. Even there are a lot of example. One of my uncle has that problem, and by regular meditation he cure this problem. But what you need to do, I will not going to explain you the final step or higher step which will cure 100%, but I will explain you the step which will help you to remove all the pain, and it will improve your problem. So what you need to do, you need to do meditation and foot soak regularly, and once you see a proper improvement in your problem, you can please contact us and we can give you little more advanced step. There is a oil which you need to vibrate. I will explain you how to vibrate that oil, and that you need to apply on the arthritis, and then you can able to cure your problem. Okay. Then there is a one more question: how can I reduce the stress of family and lot of burdens? So stress, I have already explained you. Stress is like uh, is a silent killer, and this is the entry gate for all kind of disease. So to handle stress, the biggest method is you need to do a regular meditation. Once you do meditation, you will observe that your left side and right side is in a balance. Your left brain and right brain come into the balance, and that time it will help you to reduce all kind of burden, all kind of stress. So thank you. Very good question. There is one more question, sir. Does it help in a mental balance along with the physical capability? Yes. So if Advocate Atiti ma'am is there, I will like to request you if she can take the question. Atiti ma'am, you are there? Okay. So Bhageshri ma'am, you are there? Can you take this question? Ma'am, you are on unmute.
It's a very nice question. I would like to repeat once again that question.
Sir, does it help in mental balance along with physical capabilities?
Yes, definitely it will help. Our body is everything controlled by central nervous system, and this can be very easily we can come into balance through meditation, because meditation physically we can trigger our left and right sympathetic nervous system, but meditation, after now we have our kundalini has been awakened, this travels in a central parasympathetic nervous system, which will relax our brain, and which is not possible by physical exercise, because this parasympathetic nervous system, it's everything as we have seen the earlier first video, where the column of the energy when the spirit enters through our brain, the column of rays travel through our spine, and they get into converted into three channels. These are the three energy channels. So, and there are 7 energy centers in our parasympathetic nervous system. And since we meditate, when we meditate, the hidden energy, that Kundalini energy, it start working, traveling in the central path, that is on parasympathetic nervous system, and it moves to every energy center, that is plexus, different 7 plexus we have. When it travels there, it energizes all the centers, and through that, um, the energy centers start working in a right way, and in turns it improves every organs in a body. So when you start practicing the follow-up sessions, there you will start witnessing all the spine problem or spondylitis or the constipation or the family stress, every this system, the whole entire nervous system is energized and it is relaxed. When the Kundalini energy comes to brain, all the nerves are connected to the center part of the brain. This energy, when it enlightens our brain, it gives lot of relaxation, and which improves all the organs in our body, and we will get rid of the diseases or the problems whatever we are having. It's not at all an issue. I can give one of my example. Some couple of years I had just fallen, and my tailbone, that is spine, coccyx bone, which we won't use, but it's very important. It is the base, and it was fractured. So that coccyx bone, I have approached to many hospitals, orthopedic doctors. Even in my family, there are 2 orthopedic doctors, and I have asked how to again the bone should be reconnected, or else I will be like throughout my life I'll be suffering with that pain. And everyone suggested that use a donate cushion, and you have to change the lifestyle. You cannot ride the vehicle, and you cannot sit straight on the floor. You cannot, your spine cannot touch on the floor. Like that they suggested, and it was a very difficult thing. Since I had been practicing for more than 20 years, I knew that through Sahaj Yoga everything will be cured, but yet I was very curious that through medical, can I get any help so that I can get a better treatment. But later didn't find any good result. I didn't get any pill or any treatment medically. So I started working on Muladhara, and within couple of week, 1 or 2 week, the pain was everything vanished, and I didn't feel any pain. Then I didn't even stop riding my vehicle. I had put the donate cushion on my vehicle, and I started traveling. I used to use that cushion for few months. Then later on, when I took, after 1 year, when I took the X-ray, the bone was completely again rebuilt and connected, and my spine was okay. And there is no fracture portion. The report has come, and so this I have attained through meditation. So any spinal problem or I've seen one of my friend who had met with an accident with multiple fracture, and when they went through this meditation, and by regular practice, they went twice for operation, and twice they had put the rod, everything, but it was not okay, the bones and all. And then through this meditation, now they are very fine, and the bone has been corrected through Kundalini awakening and regular practice of meditation. So this is a very fine results which we will find in Sahaja Yoga.
There is one more question, but still it's very interesting. I would like to request Bhageshri ma'am to take this question.
Yes.
Suggest a simple meditation yoga for working woman. So you are working woman, so I will request you to take this question.
Thank you. Since I'm working in Women and Child Development Department, I have lot of assignments, and I am an executive person. Every day I have to travel for more than 100 kilometers. I easily manage home and office, and I finish all my tasks very efficiently. And I have lot of time in spreading this meditation and conducting sessions in my workplace environment, since it is very effortless. I conduct meditation in rural villages where children, small kids, aged women, all age groups of people, everyone can do wherever we are. These programs, how today it has been conducted, we are taking these sessions in rural area, and even kids, small kids, little kids, where our Anganwadi schools are there, they are below 5 years and 6 years. For those kids also we are conducting, and all the working people are women's. We everyone is practicing, and they are coming out of the stress, and they are telling, yes, I'm very happy. I was very stressed up with my work or a office or a family, but now I'm enjoying. Within a week they are finding it difference, and they are continuing and giving very good feedback. We have a lot of examples. Many people are practicing, and it's really very simple. Hardly 3-4 steps for 10 to 15 minutes every day. You start practicing, then you start enjoying and continue for longer time, and you will be able to manage wherever you are. You can meditate. That's why I told you, in leisure time you can do, morning you can do, afternoon, evening, anytime. It's there is no condition at all. It's a very effortless and spontaneous meditation, which will be understanding much better if we regularly attend our follow-up sessions. Thank you. Any
Thank
more
you.
questions?
So I would like to add one more thing. Like the Bhageshri ma'am is working in a child department. Also, she's conducting a lot many Sahaj Yoga program. Apart from this, all this time she is a very good cook also. So you can enjoy a very tasty food if you are going to the Mysore.
Yeah,
So
yeah. I invite everyone. You can come and enjoy, and it's a beautiful place. You get lot of place to visit also.
yeah, so all thing can be managed with yoga and meditation. So you can always try a very good method. So thank you. We want to give a sincere thanks to college management team for inviting us, and maybe Manisha ma'am and Chitra ma'am. We would like to request you that this association should not be for one session. We can have many more session. We have a 7-week session. Those who are interested, we can teach you advanced technique like foot soap, music therapy, and many more. And even we are open to come to physically also, like a lot of our team member are located in Bangalore. They can come and take a physical session, or online session is very good. So we are happy to help you in all the way. And this is Sahaj Yoga is totally free across the world. So there is no hidden charge, there is no money, there is no commercial angle, nothing. We are just helping to the society because this method help us. So we thought we will help you. So we all are like engineer, director, IPS, doctors, very senior position people, and we are just wanted to help the society. So thank you very much, ma'am, for giving this beautiful opportunity. Special thanks for Manisha ma'am for coordinating so beautifully, interacting with us and sharing all the minute detail, and very good coordination from Chitra ma'am. So over to you, Chitra ma'am.
Thank you, sir. Sir, we have one more question from Shashikala ma'am.
Okay. One of my friend who does meditation, but he had heart issue and attack. What could be the reason? So Bhageshri ma'am, Atiti ma'am, you want to take this question? Advocate Atiti ma'am, you are there? Bhageshri ma'am?
Okay. It's very easy. This is a very simplest thing. What it will happen? We keep our right hand on our left heart, and left hand to us to a guru, Shmataji Nirmala Devi, and just pray that I am the spirit. This prayer itself opened the heart before her presence, and it awakened a spirit. Spirit is the one which is keeping us alive, and because of that we are alive. If the spirit is not there, we won't be alive. So this is the simplest thing, and this spirit reside inside our heart. It is its home, it's a temple, and by just praying that truly I am the spirit, and cleansing our heart, slowly we will get rid of all the problems which are related to heart, because the heart is the one which controls a whole central nervous system or autonomous nervous system. This is an autonomous body, where a subtler level, in a subtler level we are understanding, and many I have seen one person, one of my friend, who was going for a surgery for heart surgery, and then we have experimented giving him self realization and made him for few minutes meditation. Then later on we have seen that we have observed that there was not an issue and there was no need of having that surgery, and then they have accepted Sahaj Yoga and they have come and settled down in Sahaj Yoga. And one more example I could give, when one of our old Sahaj Yogi, he went to ashram. He was old age and nobody was there. He was in old age home, and nobody was there to take care of him, and slowly he developed diabetes more, very sick, and um, uh, one of his leg was unable to live for more than a week, and he was admitted to hospital, and all the reports related to heart was not good, and he was about to go again for test in the evening, and next day he was advised to have operation. Then few of us, when we visited, and we talked to him, and we together meditated, and did some simple treatments where we learned in Saj Yoga. And evening when they went for this test, it was amazing. The reports were normal, and within 3 days he was cured from the soaring of his foot. Again, we have to understand Sahaj Yoga depends on individual, how the individual person will take to himself and how much he surrender to himself and meditate regularly. It depends on individual. Like if we have a thyroid problem in the neck, the first we have to clear our lower plexus and our channels, then automatically this thyroid also will get cured. So like that, it is related to every channels and every nervous system and every energy center. So if we regularly practice, really we will witness that we will not get any diseases. um, it may be, we should understand what are the qualities of our channels, and what are the elements, and how to meditate, and how to cleanse, and how to and we should know few techniques also that will help us. Sun surgery, yes, yes. The one who was sick, he was been practicing for 20 years, and he went to and he became very old, and he was in old age home, very alone, and stopped practicing meditation, everything. And when he got sick, that time again but he was a very dedicated person who was practicing it, and he knew that Saj Yoga will heal him and cure him. And as soon as he started meditating, that time it started working on it. Those who from their heart, physically, mentally, everything, when we accept and do it dedicatedly, sincerely, in thoughtless, then everything will work out. This is a very simple and easy method. and we will witness it how it works on us. We will be having lot many questions before we start this meditation, and after few days regular practice, then we start feeling the difference. We ourselves will witness. Then we will try to know more and practice it in a proper way, in a regular base, on a regular base. Then we will find the difference. It's not like a festival that one day we do and again we forget. That time we won't feel any changes. We have to continue for daily, about say about 15 to 20 minutes. That's all. Then you will join the group meditation or a collective meditation. Again, you will feel much better, where when all of us together sit for meditation, then we feel more interest and we feel more energy in our energy centers. Our energy level will improve because Kundalini mother has a lot of energy. She is capable to correct every single cell. She is able to connect our genetic problems also, because in the womb of the mother she has created the whole entire child, the eyes, the nose, the entire bone, legs, everything she has defined in a beautiful way. When she can do that much, when she is awakened, she can do much better. She is inside, she is looking after. When she is awakened by meditation, by our desire. That is the key point, where we must understand that only the desire, and by sitting for meditation for few minutes, that time you will witness what is happening within us and how it is improving us, how we can grow, and how it will heal. My husband is a doctor, and I have a child. Many times, if when in our childhood, if sometimes if she used to get a fever, we used to sit for meditation within 10-15 minutes. Again, we used to witness that there is no sickness, there is no fever, like that. And my husband never treated her, because we know Saj Yoga, and Saj Yoga is very fast than any other treatment. Sometimes, means we are practicing Saj Yoga, and we know how to drive it. That's why we are confident and we are telling. So once you grow in Saj Yoga, practice meditation, know everything, then you'll be able to handle the things or a situation if anything goes wrong. So it's a very subtler level and a very sensitive thing, where you will witness and find your own solution before it grow to a bigger extent. So anything can be triggered back and brought into a normal condition or a normal state, and which really it's like a magic. Sometimes we feel so many things when myself, when I felt that my bone is healed and I'm perfectly all right. So after 1 year, I left using all the cushions, and I do all the work. I drive every day for more than 100 to 50 kilometer. So I'm so fit and fine. So that confidence has given me through Sahaj Yoga. I'm a live example. Because of that, I'm so confident, and every day, morning, evening, I practice meditation and I enjoy it. And I pass on this message to everyone, because when it has benefited me, why we should not share such a good thing and such a right thing to others, where it will help to everyone. One of my friend, she's an agriculture officer, and she worked from morning till evening, and she took lot of stress and she knew Sahaja Yoga, not practicing regularly. Then her HB is in one of the peak time. What happened? Her HB level came to 6%, and she was crying the day when she came our home, and she was telling that, see, this my HB level is like this, and now I have to take a lot of medicines and treatment. Doctor has advised like that. She told. Then I told, how come? Then I asked, are you practicing meditation? Why are you taking so much of stress? Why don't you practice for a few minutes? Because since she is a working woman, she is having 2 children, relatives, everyone, and she has to balance home, work, everything. She was so sick. Then I told, you are not doing properly. Try for sit for few minutes. Then again we sat for few minutes, meditated, did some small water treatment, and after that I told to continue, and and asked her to come at least once in a week. Come to us, we will have collective meditation. In a month I have seen, and she was so much stressed. After a month, then we have checked her report. Her HB level came 11.5 within a month through this meditation without taking any pill, and she was so much confident. And all the food, everything, whatever she take, she did tried. She took very good fruit juice and good leafy vegetables, all those things she did. But the organs has to absorb all the things and come into balance. That how we work on through central nervous system, autonomous nervous system, like that. Her HB level came to normal within a month, like 11 to 11.5. So how this stress affect our organs? When the brain is relaxed, automatically our organs start functioning in a right way, because our kundalini energy, it's a powerful energy which moves to every center, all the 7 energy centers, and relaxes and improves our health. So that's why we find a very quick result in Sahaja Yoga. We need not worry. Like in a system, in computer, we want to scan. How we scan? Like that, this meditation scan us and delete all the unwanted things by simple method. So we have stored a lot of, if we have collected a lot of data within us, we can erase it. We can remove the unwanted things and keep the good ones. Like that, Kundalini Mother will take out all the things which is not required, and keeps our organs and energy center healthy, and we will be more happy and enjoy this meditation. One must go through this life process of meditation and kindly join the follow-up session regularly. Thank you. Over to Chandrakant sir.
Thank you, ma'am.
Yeah.
Thank you, sir. It was
Thank you,
really a
ma'am.
very interesting and interactive session. Like we came to know all about the act of practicing healthy habits on a daily basis to attain better physical and mental health outcomes. We saw the various dimensions of wellness like physical, emotional, intellectual, social, etc. And also we got an idea of effective stress management and also the importance of meditation, which helps us to break the stress on our life so that we can be happier and more productive. Basically, the ultimate goal is a balanced life with time for work, relationships, relaxation, and fun, and strength to hold up under pressure and meet the challenges head on. So, with all this, first and foremost, I would like to thank Shri Mataji, Dr. Nirmala Srivastava ma'am, founder of Sahaja Yoga, for this tremendous contribution. On behalf of management of MVJCE and the Department of Chemical Engineering, I would like to convey my sincere thanks to Chandrakant sir, Bhagyashri ma'am, and Aditi ma'am for enlightening all of us with the great knowledge of yoga and meditation. Thank you, ma'am. Thank you, sir.
Thank you, ma'am. Thank you very much. We can log off from the system. Thank you.
Thank you, sir. I request all the participants to fill the feedback link which is shared in the chat box. The feedback link is already shared in the chat box. Kindly fill it. And tomorrow we have a session on role of artificial intelligence in fuel cell management by Dr. M. Venkata Kritiga, Associate Professor, Department of EEE, National Institute of Technology, Tiruchirappalli. So kindly join the tomorrow's session at 9 a.m. Thank you all.